students, welcome back to your favorite channel, Vedantu Neet English. First, let me know, one second, okay. Let me know if I am audible to you, visible to you extremely clearly, if you can hear my voice. Can everybody hear my voice? Let me know in the chat box. Let me know, just give a thumbs up, ki ma'am, your voice is clear, you're extremely clear, the screen is clear. Hi Bacha, my name is Nandini ma'am and with me you learn inorganic chemistry on this channel, right? We prepare for your NEET exam basically. Let me know in the chat box if you can see me and hear me properly. Please let me know if I'm audible. Let me check otherwise. Good afternoon, Shubham. Can you hear me? Hi, Bacha. ठीक है. Everything is extremely clear. We're going to start this session. First, let me tell you, bacha, this is the part 3 of the P block, right? We have already covered 2 parts of P block where I've taught you what is P block in part 1, right? And we have learned till now group 13, group 14 and group 15, right? Today we're going to complete the rest of the groups which are group 16, 17 and 18. Very important groups. Very fun learning about those groups. Good afternoon. Hello Prasad, hello Acer. ठीक है. Chalo, let us start with the group 16. What is group 16? Group 16 is your oxygen family. Also understand bacha, P block is an extremely crucial chapter for your inorganic chemistry. Along with P block, the other thing that is very important is your inorganic chemistry practical book, right? You have a practical inorganic chemistry book. Please go through that along with the P block only and only then consider that your inorganic portion is extremely strong. Okay, I'm again reminding you, today we are going to study about the group 16 elements. Correct? 1 second, let me choose the pen color. Hi. Yes, this is also called the chalcogens family. Extremely right. Correct. The group 16 have which all elements? It has oxygen, sulfur, selenium, tellurium and polonium. Group 16 means what? That in its last orbital, how many electrons will be there? Ns2, Np, Np4. So in its last orbital, there are actually 6 electrons. Hence, the group number is 16. Can everybody see? This is the group number and this is the electronic configuration, the general electronic configuration. We are going to study about this group. What are we going to study? First of all, we're going to study about their trends, right? What is their ionic radii? What is their melting point? What is their boiling point? What is their ionization energy? Electronegativity order, electron gain enthalpy order. All these orders, first of all, we're going to study. The next thing is we're going to study their reactions with 3 elements, which is oxygen, hydrogen and halogens. That is it. That is how we will complete the entire group. Okay, everybody is understanding this part? Okay, and before starting again this P block, because we're studying for your NEET exam, I have a very crucial information to share. Once again, that NEET 2024 Crash Course 2.0 has already begun by Vedantu, right? Vedantu is providing the crash course in which within 2 months you can prepare for your NEET exam very wonderfully if you join this course. If you want that my preparation is lagging somewhere behind, I need to solve more test papers. If you have all those fundas, all those agendas in your head and you're still looking for resources, then you can bacha for sure join the crash course for Vedantu, extremely best crash course ever created. Okay, in which you will have 23 full length mock tests, 15 parts syllabus mock tests, which is very important, right? At this point of time, most of you should be revising your syllabus, and if most of you have not even started the syllabus, and this is the best opportunity because class 11th plus class 12th is going to be taught in this crash course, right? And also you're going to have so many tests, which is the which is the most required thing right now, right? You can enroll. The link is in the description box below. The next thing is, this is the online course, right? But if you're someone, if you want to join the offline classrooms, and offline attracts you the most, you think that you are more disciplined in the offline section, which means you go somewhere, sit down, and teacher is in front of you, and then teacher is telling you to do this, to do that, right? You are not in front of any screen. Then again, bacha, Vedantu is in your city. This is a very good news for all the Vedans, of all the students of Vedantu, that if you are from any of those cities which are mentioned here, that in Punjab, in Patiala, Delhi, Jhunjhunu, Pune, Nagpur, Aurangabad, and if in Tamil Nadu, if you are from Chennai, Coimbatore, Madurai, Trichy, if you are from Telangana, from Hyderabad, if you are from Andhra Pradesh, then Visakhapatnam, Vijayawada, Guntur, and Bihar, Muzaffarpur, right? We have our centers right now at these places. And if you are interested for what? Bacha, NEET 2025. Okay, if you are interested in NEET 2025 and you want to start the preparation right now, you can join these centers. And for more information, if you just want to if you want to just have some contact, like, ma'am, what is happening? If you want to just book an appointment of what is being taught there, how is the environment, then you can again go and check the link in the description box below. Once again, I need again to tell you that if you want to join the offline courses, then you can take the IVSAT exam, which is what? But nothing. It is a scholarship test, right? You do not have to pay the entire fee. If you take this exam and if you score a minimum of some marks which is required to get this IVSAT scholarship, then you can get up to 70% scholarship, which is a very, very big deal. Bacha, again, Vedantu is actually offering 100 plus crore scholarship pool, which is a lot and lot of money, right? And you can obviously avail this opportunity if you register right now. The link is in the description box below. Please get serious about your NEET 2024 or NEET 2025 exam. If you are just taking the exam this year, then the online crash course you can join if you need more help, more resources, more test series. Right? Now let's get back to group number 60. Right? This is what I have to tell you about the resources, because students keep asking me, ma'am, how to join the course, this, that. So I have to let everybody know about that. Ma'am, after P block completion, please bring the question practice session of the chapter. Bacha, along this session, I have included all the more than 10 years, 10 to 15 years of PYQs we've already done. So that is a very good practice session in itself if you just attend these 3 parts, right? Otherwise, we are definitely going to do more practice session. That is for sure, because right now we again have approximately 2 months with us, right? Yes, but in Northeast there is no center. You can join the online course, right? Online course is for these students where we cannot go, where we cannot approach you offline. That's why online is such a great platform. But again, offline is any day better, because you get to go there, you have a schedule, right? Every morning you get up, you cannot miss out on many classes when you have an offline center. In online, it just depends on my mood. Right now I want to study, so I will open this YouTube channel and study. Right now I do not want to study, so I'll sleep or do anything. Free will is not that good of a concept when it comes to preparing for such exams. And also, Vachai, keep one more thing in mind. I have very extremely crucial thing to share, that this year 25 lakh NEET aspirants are going to take this exam. This is a humongous number, 25 lakhs. Previous year, how many students took the exam? It was like approximately 11 to 12 lakh. The numbers varied between 11 to 12 lakh students. Right now, it is a jump of approximately more than 10 lakh of students. So the competition is going to be wild, bacha, wild. Even at 700 last year, people were struggling to get a good college of their own choice, right? 700 marks out of 720. So you can now just imagine about the competition this year you're going to face with 25 lakh students. So you cannot afford to miss even 1 point, in your NCERT, even one pointer that has ever been asked in your NEET exam. You cannot, you know what, you just cannot be half-heartedly prepared for your NEET exam and expect to get a good rank or even a good college or even a bad college this year, because the, you know what, the competition is going to be insane this year. 25 lakh students is an insane number, bacha. So please get serious about your NEET preparation. Very important. Now let's start the P block, group number 16. Okay, it consists of oxygen, sulfur, selenium and tellurium. Why? Okay, this group is bacha also called chalcogens. Why is it called chalcogens? Because it comes from the Greek word that it is made up of brass and it has association with sulfur, and with copper also. What bacha? Oxygen and sulfur compounds are present, you know what, naturally. That's why it's called chalcogens. You must know these. You know, what are these called? These are called random facts. So why do I include these? Because right now the competition is going to be very tough. You cannot miss out on even 1 point from your NCERT. These, you know, faltu ke points which everybody consider. What point is that, ma'am? This is a very weird point. Nobody is going to ask. People are going to ask this. People are going to ask this. Okay? Now the next thing in group 16 is their occurrences. Very important for every group. You must know what are the percentage of each element. Next thing is in what minerals they are found, what is their formula and what is their chemical name. These things are very important. For example, we all know that oxygen is the most abundant element in the earth. Okay, remember this thing. It is the most abundant of all the elements on earth because it consists of 46.6% of mass of earth's crust. And even in your air, there is so much oxygen. There is approximately 21% oxygen in air and 46.6% in the earth's crust. So oxygen is the most abundant element on earth. Next abundance we're talking about is sulfur. Okay? In earth's crust, sulfur is just 0.03 to 0.1%. Very important funda. Next is, how does sulfur exist in the earth's crust? How is it found? In the form of minerals, right? In the form of sulfates such as gypsum. Gypsum's formula is this. Please remember the formula and the chemical name of all these compounds because it has been asked in the JEE exam also this year. So it will definitely be asked in your NEET exam. All these chemical formulas, all these mineral names are very important. Next is in Epsom salt. Epsom salt formula is MgSO4.7H2O. Next is in barite, again sulfate is found. Next is, this is the form of sulfates, and the other form in which sulfur is found is in the form of sulfides. For example, in galena, in zinc blende, which is zinc sulfide. In copper pyrites, for example, CuFeS2 are called as copper pyrites. And traces of sulfur bacha are also present in hydrogen sulfide, which is found in your volcanoes, right? From volcanoes, which gas is released? Your hydrogen sulfide is released, right? Again, where else sulfur is found? In the organic components, such as in eggs also sulfur is found. Proteins, garlic, onion, mustard, hair, wool contains sulfur. Next elements are selenium and tellurium. How are those found? They are formed as metal selenides and tellurides in sulfide ores. Again, they are found as sulfide ores. Remember this thing. Okay? Selenium and tellurium are found as sulfide ores, and polonium is bacha a radioactive element. Correct? And how it is formed? It is a decay product of thorium and uranium minerals which are used in nuclear reactors, right? You have all of you must have seen the Oppenheimer movie. In Oppenheimer, can anybody tell me which which radioactive compound was used? Was it thorium or was it uranium? Who can answer this question for me? Was it thorium or uranium? And your polonium is a decay product of both minerals. Remember this thing. Okay, decay product of both. Good afternoon, Bhumika. Good afternoon. Okay. Next is, now we're going to study from group 16. What did I tell you? I told you about their occurrences. How are they formed? The minerals are very important, right? Next thing is very important is their electronic configuration. The general electronic configuration is NS2NP4. Nobody should have any doubt in this. Okay? In NS2NP4, can you see? In sulfur, from sulfur bacha first time, from selenium bacha first time d orbitals are introduced, and in polonium bacha first time f orbitals are introduced. Remember this thing. Okay, d orbitals are first of all introduced in selenium and f orbitals in polonium. Okay, this is the only thing we got to know about electronic configuration. All the trends we're going to study, but again in this this is a very easy group. Why? Because all the trends are extremely easy. It is what you expect. Hence, there are lesser chances to get questions out of these trends. I'm already telling you this, but still you should know. So what is the atomic and ionic radii order? See, but what happens in inorganic chemistry? Most of the questions are found from those areas where there are exceptions present. In group 16, when we're talking about trends, they're going to be the least exceptions possible, right? So trends are like the least asked questions for your NEET exam. But still we're going to study because it's in your course, they can be asked. So what happens to the atomic and ionic radii? So oxygen has only 2 shells. In sulfur, what happens? It has 3 valence shells. In selenium, what happens? It has 4 shells. So can you see? As I am going down the group, what is happening? The number of shells are increasing. If the number of shells are increasing, it means the radius will increase. Hence, the atomic or ionic radius is exactly as expected. For example, oxygen has the least radius, then it is your sulfur, then it is your selenium, then it is your tellurium, and then it is your polonium. Okay? And also remember, bacha, oxygen is exceptionally small. Exceptionally chotu molecule, exceptionally small molecule. Exceptionally, it is a very, very chotu molecule. Okay? Understood this part? Now let's move on to the next trend, which is the ionization enthalpy. What is that? For example, I took a atom over here. Okay, this is the atomic structure. Now what happens from the valence shell? I need to take out the electron. From where I'm taking out the electron? From the outermost valence shell. So the energy required to take out the electron from the outermost shell is called the ionization energy. Everybody understands that? Okay? Now what will happen, bacha? If the radius is very, very small, right? If the radius is small, it means what? That the outermost electron is most attracted to the nucleus. Hence, it will be difficult to take out the electron. But as the radius is increasing, the outermost electron is far away from the nucleus. Hence, it is easier to take out because it is experiencing least attraction. Hence, what happened? When I'm moving down the group, the size of the atoms is increasing. Hence, the ionization energy will decrease. Okay, so ionization energy order is oxygen has the maximum ionization energy, then your sulfur, then your selenium, then your tellurium, and then your polonium. What is happening? As the size is increasing, ionization energy decreases. Okay, this is the order we've been studying since class 11th. Okay, nothing new in this. Next is electron gain enthalpy. What does that mean? Electron gain means, for example, in your I've made a three shell of atom. Now, what is happening in group 16? How many electrons are there in the outermost orbital? Ns2, Np4. How many electrons are there? 6 electrons are there in the outermost orbital in group 16, right? So now it needs 2 more electrons to complete its octet or to gain the noble gas configuration, right? If I give it what? If I give it 2 more electrons, then it will become 8 electron species, which is a stable species, right? So this gaining of electron is actually called electron gain enthalpy. Remember this thing. This gaining of electron is called electron gain enthalpy. Right? Now, because I'm adding something, whenever you are adding something, you're making a bond. If you're adding something, making a bond, it means what? That this electron gain enthalpy value will always be a negative value. Remember this thing. Okay? Will always be a negative value. And more negative the value, it means easier will be the electron gain enthalpy. Hence, the order of electron gain enthalpy, bacha, is sulfur is the most, then your selenium, then your tellurium, then your polonium, and then your oxygen. Can you see here that bacha, oxygen has the least negative? electron gain enthalpy. Why? Because again, bacha, oxygen is a chotu sa atom, right? Oxygen is a chotu sa atom. Now in chotu sa atom, if you try to add 2 more electrons, they will experience maximum repulsion. Oxygen is chotu sa atom. Now you are adding 2 more electrons in the already smaller atom, right? So what? They will experience the most repulsion. Hence their electron gain enthalpy is the least negative. Okay? Sulfur has the most negative electron gain enthalpy value and oxygen has the least electron gain enthalpy value. Okay? Very, very important order. From this order, there are questions asked many, many times. Okay? This is the order followed. Now, next order that we're going to follow is the electronegativity order. Right? Right? Hi, Kamra Muhammad. Okay? Electronegativity means what? In electron gain enthalpy, I told you कि the electron is added to the atom, right? That was electron gain enthalpy. Electron negativity is what? For example, this is the atom, right? So electron negativity is just the tendency to attract electrons. There is a difference between both the things. Tendency to attract electrons is called electronegativity. I'm writing it here. Tendency to attract electrons. This is called bacha electronegativity. But in electron gain enthalpy, what was happening? The electron was adding. Idhar pe we are not adding, we are just attracting. Difference. Here pe the electron is just floating. It is just floating. It is not marrying the electron. But electron gain enthalpy, it marries the electron. Right? So just understand it with this funda. Now next is what is the electronegativity order? Again, oxygen is the most electronegative element. Then it is your sulfur, then it is your selenium, then it is your tellurium, and then it is your polonium atom. Remember this thing. Okay? Now, if this is the electronegativity, what am I saying? As I am going down the group, the electronegativity is decreasing, right? Oxygen is the most electronegative, polonium is the least electronegative, which means what? As I am going down the group, the electropositive character is increasing, isn't it? If the electronegativity is decreasing, matlab the opposite, electropositivity increases down the group, which means what? Which means if the electropositivity increases, it also means that your metallic character increases down the group. Remember this thing. As you go down the group, the elements become more and more metallic in nature. They become more and more metals. Okay? Remember this thing. This point is clear to everybody. Now, next thing that we're going to talk about is the physical properties. We have talked about the atomic properties. What were they? They were the radius, the ionization energy, electron gain enthalpy, and electronegativity. So, these 4 properties we discussed for every group. Over. Now, we're going to study their physical properties. How are they in their physical state? What is the physical state? For example, oxygen and sulfur, both of them, bacha, are your non-metals. Remember this thing. Both of them are your non-metals. Sulfur and tellurium, both of them are your metalloids. Remember this thing. Very, very good metalloids. Next is your polonium, bacha, is the only metal in this group and it is also a radioactive element. I just mentioned, right? It is a radioactive element and its half-life. What is the half-life, bacha? Its half-life is just 13.8 days. Remember this thing. Its half-life is just 13.8 days. Happy noon. Somebody is writing happy noon, ma'am. So, hi Ashwarya and hi Umair Afzal Loan. Okay, what a name. What a name. Yeah. So, everybody understood this point. These 2 are non-metals. Next 2 are metalloids. And the next is metals. The first physical property we discuss is what are metals, what are non-metals. So, we have discussed that. Okay. Now, next thing that you should know, all of them, all show what? All show allotropy. All show allotropy. Remember this thing. What is allotropy? I've discussed so many times with you. It means physical forms. They are present in various physical forms. To remember what is allotropy, remember carbon also have so many allotropes. Carbon is also present as diamond and carbon is also graphite. But both of them are two different physical forms, right? But all are made up of just pure carbon. Similarly, oxygen, sulfur, selenium, tellurium, polonium all show various physical forms which is known as allotropy. Okay, the next thing that you should know about them is let's go. Let's talk about their melting point, boiling point and density. Okay, so what happens to their melting point, bacha? So the melting point order is oxygen has the least melting point. Remember this thing. Okay, very less melting point, and then it is your sulfur, then it is your selenium, then it is your tellurium, and then it is your polonium. Also remember, bacha, melting point depends on the crystal structure. Always remember, melting point only and only depends upon the crystal lattice. For example, bacha, oxygen is just a diatomic molecule. Diatomic molecule means what? That only O2, in maximum cases what happens? O2 is found. Okay, but sulfur, selenium, tellurium are what, bacha? These are all your polyatomic molecules. What are they? They are polyatomic molecules. For example, sulfur is found as S8 molecule. So can you see? In one molecule, there are 8 sulfur atoms present. Hence, its melting point increases. Okay? So therefore, oxygen has the least melting point and then it increases in this order. Remember this point. Next is again boiling point follows the same order. Boiling point follows the same order. Oxygen, very less boiling point, then sulfur, then selenium, then tellurium, and then polonium. So this is the boiling point order as well. Now density. What is the formula for density? Density is mass upon volume, right? Mass upon volume. So as I'm going down the group, what is happening? The mass is increasing, right? So hence the density will also increase. So therefore the density order is oxygen is the least dense, then sulfur, then selenium, then tellurium, and then polonium. So these are very important orders, can be asked in exams, and you should know about them. You should know the reason why the melting point and boiling point of oxygen is so less, because oxygen is mostly a diatomic molecule while sulfur and everyone else are polyatomic molecules. Hence its melting point, boiling point is increases many folds. Correct? Everybody understood that? Next is the oxidation state. We're going to talk about their chemical properties. Okay? In chemical properties, we're going to discuss their oxidation state. Very important. Now again, I'm going to write their general electronic configuration, which is Ns2Np4, right? This is their general electronic configuration. Now what can be their their oxidation state? So one funda is if it gains 2 electrons, right? If I'm able to add plus 2 electrons to this, what can happen? Then it's going to show -2 oxidation state, isn't it? -2 means what? That we're giving it 2 electrons, right? And what else oxidation state does it show? It also shows, bacha, these kind of oxidation state. For example, oxygen shows -2, -1, +1 and +2. Sulfur shows again -2, +2, +4, +6. So can you see oxygen does not show +6 oxidation state. Why? Because oxygen has no d orbitals. Correct? So it doesn't show +6 oxidation state. It only shows -2, -1, +1 and +2. Similarly, sulfur shows -1, +2, +4 and +6. Selenium also shows the same. Tellurium also the same. But polonium only and only shows +2 and +4 oxidation state. So what is the trend that you're observing? The trend is as I am moving down the group, what is happening? You should know the trend. The trend is as I am moving down the group, what is happening? The -2 oxidation state. What is happening to the -2? -2 oxidation state is actually decreasing. Stability. I am also writing here, bacha, stability. Correct? The stability of -2 oxidation state decreases, and also of your +6 oxidation state also decreases. As you go down the group, +6. Why is +6 decreasing? Due to the inert pair effect. Due to inert pair effect. Right? Now, what is inert pair effect? I'm not going to tell you because I've told you already in 2 lectures previously. This is a part 3 that we're doing. Right? So, what is happening here? That the +6 is also decreasing as we go down the group. Okay? So, what are the most common oxidation state? I'm writing it here. So, bacha, the most common oxidation states are actually your +4 and +6. Okay? These are your most common oxidation states. Okay? Now, let's talk about just oxygen over here. So, what happens with oxygen, bacha? Ma'am, your F and D blocks are great. Thank you, Deepak. Thank you so much. Even my P block elements notes are the best. I'm telling you already, nobody teaches in so much detail, right? See, detail is important, especially when 25 lakhs aspirants are taking this exam this year. So the competition is going to be very, very tough. Every point, every fact is very important. Please understand this. Now, we're talking about the oxidation state. Most common, I've told you, +4 and +6 for group 16. With oxygen, what happens? I already told you, oxygen cannot show +6 oxidation state. Why? Because it do not have any d orbitals. Next thing about oxygen is it is a highly electronegative element, right? It has the second highest electronegativity in the entire periodic table, right? For example, fluorine has the highest electronegativity in the entire. Next comes your oxygen. Okay? Due to the high electronegativity, bacha, what happens? It mostly it shows which oxidation state? -2 oxidation state. Remember this thing. Okay? There is only one exception with oxygen, except in which molecule, bacha? OF2 molecule. OF2, but can you see here now oxygen is attached to more electronegative fluorine, right? Between oxygen and fluorine, which is more electronegative? Fluorine. Hence, which will get the negative oxidation state? The more electronegative atom gets the negative oxidation state. Hence, oxygen here will get a positive oxidation state of +2. Remember this thing. Of oxygen I'm talking about. With oxygen, most common is -2 oxidation state, but sometimes it also shows +2. For example, in the case of OF2 molecule, because fluorine is more electronegative. Correct? Now let's talk about sulfur, selenium and tellurium. So all three of them shows +6 as well as +4 oxidation state. Okay? +6 as well as, sorry, only one second. Let me rub this. Okay. Please. No, this. Yes. Let's move on to the next page so that's easy. Actually, sulfur, selenium and tellurium, all of these shows two kind of oxidation state. They show +6. They show +6 oxidation state with fluorine and +4 oxidation state with your oxygen. Remember this thing. With oxygen, it shows +4 oxidation state, and with fluorine, it shows +6 oxidation state. Okay? Now, I already discussed with you that as we go down the group, what is happening? When I'm going down the group, stability of +4 oxidation state increases and +6 decreases. Right? Anybody has any doubt in this? Okay, the +4 is increasing as we go down the group. So this is the basic major points that you should know about oxidation state. Next thing is, again, another important thing is both +4 and +6. I told you, right? I told you that most common oxidation state are +4 and +6, and both of them form what compounds, bacha? They form covalent compounds. Remember this thing. Both of them form covalent compounds. Why? Because losing 4 or 6 electrons is very difficult. Hence, it is easier to share electrons. Hence, sharing bonds happen with group number 16. So, right now we talked about number 1 chemical property, which is their oxidation state. What did I tell you? That it shows variety of oxidation state. But the most common in the group 16 is the +4 and +6. But oxygen, because it is very small, high electronegativity, it is an anomaly. Hence, with oxygen, the most common is actually -2 oxidation state, correct? And also, sometimes it shows a positive oxidation state only and only when it is connected with fluorine. That is the only case when oxygen will show the positive oxidation state. Next thing that we discuss is sulfur, selenium and tellurium. What happens with these three? They show the +6 and +4 oxidation state, but +6 is shown with fluorine and +4 is shown with oxygen. Okay? Next thing that we discuss, add polonium. Polonium will be more stable in the +4 oxidation state, correct? Because as we go down, lower oxidation state becomes stable. So this thing should be clear about the oxidation state with everybody. Yes, bacha, I cover every more than 15 years of PYQs we do in this session. Vision 720 is asking me. Okay, now oxidation state is over. Now we're talking about the anomalous properties of oxygen. In every group, the first element will behave anomally, will be an anomaly. Why? Because of so many things. Number first thing, because oxygen has what? Because it is a very, very small size element. Number first condition. Number second is it has high electronegativity, right? And it also has high ionization energy. Number fourth, it has no d orbitals. Okay, due to all these four factors which we discuss in every group, the second period element, this is bacha second period, this belongs to the second period, right? It has only p orbitals and it has no d orbitals. Hence, due to that, it shows some very anomalous behavior, which means what? That the property of oxygen will be different from the rest of the elements of group 16. And now, what is the difference in their properties, bacha? For example, bacha, oxygen can show maximum covalency. Maximum covalency. What is covalency? Covalency is number of bonds, right? So oxygen shows maximum covalency of 4. It cannot form more than 4 bonds. Remember this. Okay? But usually how much it forms, bacha? Okay? Rarely exceeds 2. Okay? So rarely, see, most of the time it will form just 2 bonds. But sometimes it can expand up to 4 bonds, but not more than that. But other elements of group 16, what is the case with them? They can show more covalency than 4, right? They can expand their octet because from sulfur to polonium, what happens? The d orbitals are present. In sulfur, there are vacant d orbitals. From selenium, there are filled d orbitals present. So from sulfur to polonium, there is a presence of d orbitals. Hence, they can expand its valency and they can form more than 4 bonds. More than 4 bonds can be formed. Remember this thing. Okay? So this is about the anomalous behavior of oxygen. Very, very easy. There is no other thing that we're going to discuss in this thing. Next thing is we are there with the reactions. Right now, what all have we covered about the group 16? I told you about their atomic trends, right? Let's revise everything so that everything is clear in your head like a picture, like a movie, right? Number first thing, the trends that we discuss in the atomic properties, their radii. What happens to the radii? What happens to the ionization energy as we move down the group? What happens to the electronegativity? What happens to the electron gain enthalpy? What happens to the metallic character? Then we discuss their physical properties, right? In the melting point, boiling point, density, all this we discussed. And next thing that we discussed was their oxidation state. What are their common oxidation state? What oxidation state oxygen shows, right? And what oxidation state increases down the group and decreases down the group, right? So all these things we have discussed, over, done and dusted. Now we are back to the last part of the group 16, which is the reaction part. Okay? So we're going to see reactivity with 3 elements every time with every group: hydrogen, oxygen and halogen. First of all, let us start with the hydrogen part over here. Okay? The hydrogen, reactivity with hydrogen, what happens when you react any group 16 element with hydrogen? It forms a compound just like H2E, right? This kind of compound is formed. What do I mean by that? For example, with oxygen, it will form H2O. For example, with sulfur, it will form H2S. With selenium it will form H2SC. With tellurium it is forming H2Te, and with polonium it is forming H2PO. ठीक है? With बच्चा polonium not many reactions are studied. Why? Because it is a radioactive element. It has a short half-life, right? Just in days it gets over. So more reactions of polonium are not studied. So we're not going to include polonium in the reaction part. Correct? In the atomic properties part, we have studied about that. So this is, what are they forming? These are called bacha hydrides. What are they called? These are called hydrides. Okay? So we are forming hydrides of group 16 like this. Now we're going to study properties of these hydrides. Correct? H2O, H2S, H2SC, H2T. What are their properties? Okay? The number first property is their physical state that you must know. 1 second. Physical. Okay. So I will discuss the physical state with you first of all. So bacha, the H2O. The H2O bacha, only physical state. Let's study about their physical state. Okay. In physical state what happened? H2O is a liquid. Why? Because in H2O there is a possibility of H bonding, isn't it? So because in only and only H2O, H bonding is possible, hence H2O is a liquid. The other things that are gases, rest hydrides bacha, rest of the hydrides are poisonous gases. Remember this thing, they are all poisonous gases, okay, with bad smell, okay. They're all poisonous gases with bad smell. This is about the physical properties of the hydrides. Next, let's learn about their chemical properties more. So these are the hydrides we're going to study. H2O, then H2S, then H2SC, then H2Ta. Now let us look at their acidic character. What do you think will happen to the acidic character as I am moving down the group? What is meant by acidic character first of all? It means anything which easily gives away the H plus ion, isn't it? That is called the most acidic. So which easily gives away the H plus will be more acidic. Now these are hydrides, right? So when is it easier to break the hydrogen bond? When the bond is long, right? So as the bond length increases, so when I'm going down the group, bacha, what is happening? If I'm going down the group, the bond length is increasing because the atomic size is increasing. Tellurium is the largest size, then selenium, then sulfur, then oxygen, right? So as the size is increasing, the bond length will also increase, and longer bond lengths are easier to break, right? So if I'm going down the group, the acidic character will definitely increase, isn't it? So acidic character increases down the group because it's easier to break the bond. Okay? Next, we're talking about reducing character. Again, what is reducing character means? Which easily gives away hydrogen, right? Which easily gives away hydrogen is the most reducing agent. Okay? So again, the same order will be followed. As we go down the group, the bond length is increasing. Hence, a hydrogen bond will break easily, right? So it will increase again down the group. But remember one thing, that H2O is a non-reducing element. H2O does not reduce. It is not a reducing agent. Okay? Otherwise, the reducing character increases down the group. The funda is clear. You don't have to mug up. See, funda is clear. Now, acidic means what? Which gives away H plus easily. Hence, longer the bond, easier to break. Hence, the acidic character increases down the group. Easy part. Reducing character, again, as we going down the group, the bond length is increasing. Easier to break. Longer bonds are easy to break. Hence, reducing character also increases down the group. Okay? Next. Okay, due to less, wo same reason that is written over here that I explained to you. Next is hydrides properties. Physical state, we already discussed that H2O is a liquid, right? The rest are poisonous gases. I already told you. Okay? Rest hydrides. Rest hydrides, bacha, are your poisonous gases with bad odor. है ना? With bad smell. I already told you this thing. Next is their boiling point. Again, what do you expect? Boiling point depends on what? Boiling point depends on the size, and as the size increases, the van der Waals forces increases, hence the boiling point will also increase. Okay? So the boiling point order, bacha, is, सबसे पहले H2S has the least boiling point, then H2SC, then selenium, then tellurium hydride, and then your at the last is your H2O. Why? Because in H2O there is a presence of H bonding. So H bondings are the difficult to break, hence their boiling point increases. ठीक है? So only H2O is the exception over here. Otherwise, the boiling point increases as we go down the group, as the size is increasing, van der Waals forces is increasing, hence the boiling point also increasing. So therefore, but H2O is an exception because H2O has H bonding in it, so it has the maximum boiling point. Now is volatility. In your exams, many times what do they do in order to confuse you? They will not ask you the boiling point. What they will ask you instead? They will ask you the volatility. So volatility means what? It means something which has the capacity to become gas, right? Volatility means what? To become something which has the capacity to become gas very quickly, right? Which is the most volatile compound which has the capacity to become gas at the lowest temperature, right? So volatility order is एकदम opposite of the boiling point order, right? Lower the boiling point, more volatile will be the substance. So the volatility is H2S is most volatile, then H2SC, then H2TE, right? And then your H2O. Correct? Everybody understood this point? Okay, so this is the ulta order for the volatility. Now for your hydrides, we're going to look at their bond angles. Why? Because what is the structure of hydrides? H2O has a structure just like this, right? H2O has a bend shaped and there are as a presence of lone pair of electrons also, right? So can you see that a bond angle is formed within them? So H2O will have some bond angle. Next will be the H2S bond angle, right? So H2S will also have some bond angle, right? So what is the order of their bond angles? So bacha, what happens about bond angles? So H2O actually has the highest bond angle, then your H2S, then your H2SC, and then your H2TE. Remember this. As you go down the group, the bond angle is decreasing. H2O has the maximum bond angle. Okay? Next is thermal stability. How do you define stability, bacha? We are talking about the stability of hydrides, which is the form of H2E, right? Hydride stability. So, which will be more stable? So, where the H bonding is the most difficult to break will be the most stable hydride, right? So, stability order is again H2 is the most stable, then your H2S, then your H2SC, and then your H2TE. So as I'm going down the group, as the size is increasing, what is happening? The bond length with hydrogen is also increasing, hence it is easier to break. Hence, as I'm going down the group, the stability is decreasing because H2O, the bonds will be very, very closer to each other. See, oxygen is a chotu molecule, it's a smaller molecule. Hydrogen is also a chotu molecule. So both of these small molecules will form a very strong bond, and strong bonds are harder to break. They have the highest bond energy in them. But as hydrogen is a chotu molecule, but tellurium is a bigger molecule. Hence, the bond formed between them will be the least stable because it is easier to break. It will be a longer bond. Hence, least bond energy easier to break. Hence, the stability is again this. Now, again, reducing power we already discussed, right? In the last thing, I'm not going to write it again. Next is the dissociation constant given in your NCERT, hence I'm discussing it. Dissociation constant means what? Which has the ability to dissociate in water easily, right? Which has the ability to dissociate in water easily, and you'll be surprised to know the trend. What is the trend for dissociation constant? H2O has the least dissociation constant, right? It is the least dissociation constant, then it is your H2S, then it is your H2SC, and then it is your H2TE. So can you see that tellurium, hydride of tellurium has the highest dissociation constant even compared to water. Okay, the water is not easy to break, but hydride of tellurium is easier to break. Okay, understood? So we've completed hydrides. So we've completed, like when I react group 16 elements with hydrogen, I get hydrides. And then we studied the properties of that hydrides, whichever is important, their acidic character, their reducing nature, their thermal stability, boiling point, melting point, everything we've discussed. Now we're going to study. Okay, before that, we have a PYQ on our screen. Who will answer this PYQ for me? Who can answer this PYQ from me? This is a Neet 2022 question for everybody watching. Given below are two statements. Statement number 1, the boiling points of the following hydrides of group 16 elements increases in this order. Is this boiling point order correct? Is this boiling point order correct? No, this is a false order, right? Because what is the correct order, bacha? What is the correct order? Actually, H2O has the highest boiling point, right? Because H2O has H bonding in it, right? H2O has H bonding in it, hence it has the highest boiling point. So this is the wrong order. So statement 1 is false. Statement 2, the boiling points of these hydrides increase with increase in molar mass. This is again a false statement, bacha. Why? Because that is true at some point. For example, this is your group 16. Group 16 is oxygen, sulfur, selenium, tellurium, and polonium, right? This is the your group 16 elements, right? So as I'm going down the group, what is happening? The size is increasing, correct? And the molar mass is also increasing, but their boiling point only increases from sulfur to tellurium, and your oxygen actually has the highest boiling point due to hydrogen bonding, and that hydrogen bonding reason is not mentioned here. Hence, this statement is a false. This is a half correct statement. Okay? Half correct means what? That from H2S to H2SE to H2TE, as the mass is increasing, the boiling point is also increasing. This is a true statement. But later on, what is happening? H2O actually has the highest boiling point. So they have not mentioned the reasoning for H2O. Hence, this also becomes a false statement. And the correct answer will be both statement 1 and statement 2 are false statements. Okay? Everybody understood? Please, if such things are given in an exam, do not make the mistake that, if half of the statement is correct, then it is not a correct statement, because the statement should be correct as a full thing. Okay? Next is Neet 2021 question. Neet 2021 question on your screen. In which of the following arrangements the given sequence is not strictly according to the properties indicated against it? Okay? Now, as I've attached it in the group 16 PYQ, hence just directly go to the group 16 right now. Let us just directly go back to this. Now they have given you the increasing pK value. In exam, you cannot do this obviously, but right now we're solving PYQs according to group wise. Okay? So here they have given you the increasing pKa values. What is pKa? Understand this thing, bacha, ki pKa values are inversely proportional to your acidity order. Remember this thing. pKa values are inversely proportional to the acidity. It means as the acidity will increase, the pKa value will have to decrease. So we know the acidity order. I just taught you the acidity order, right? As I'm going down the group, what is happening? The bond length is increasing with hydrogen. Hence, it is easier to break the H bond. Hai? So acidity order is what? Acidity order is H2O is the least acidic, then H2S, then H2SC, and then your H2TE, right? This is the acidity order. The tellurium is the most acidic compound, but in the question they have asked you the pKa order, which will be reversed, which means H2O will have the highest pKa, then your H2S, then your H2SC, and then your H2TE. Everybody is understanding this point? Good afternoon, JK. Good afternoon. Okay, everybody understood this? So pK is the inversely proportional to acidity. Okay? Next is again a PYQ from Neet 2019 on your screen. Which is the correct thermal stability order for H2E? Correct thermal stability. Who can answer this? I just taught you. So as we go down the group, the thermal stability of the hydrides decreases because the hydrogen is a very small molecule, and as the size of the atom is increasing, the bond length also increases, hence the bond length is weaker. So the thermal stability order is, I think, option number A seems to be the correct answer, right? So H2O, it has the highest, it is most difficult to break the H2 over here because both hydrogen and oxygen, chotu molecules, stronger bonds. Then H2S, then H2SC, H2T, H2PO. So A seems to be the correct option. Now again AIPMT 2014. See, from the hydrides, see, can you see? From just the hydrides, so many questions are asked in so many years. Okay? Now the acidity of AIPMT 2014 question, acidity of diprotic acids in aqueous solution increases. Again the acidity order is asked. I just taught you which one will be the most acidic. We know that tellurium will be the most acidic, then selenium, then sulfur. Okay, so A again seems to be the correct option. Okay, this is the acidity order. Next is, we are back with the next reaction series. So in reactions of every block, we're going to study the reactions with three things. I again and again keep telling you, with hydrogen, oxygen and halogens. So with hydrogens, we have completed. Now we are talking about the reactivity with oxygen. So what kind of oxides they're going to form, bacha? They're going to form two kinds of oxides, EO2 kind of oxides and EO3 kind of oxides. Okay? So bacha, remember that in these oxides only ozone and SO2, only ozone and SO2 are gases, rest are solids. Okay? For example, SeO2 is a solid. Okay? These things you should remember. So these are the kind of oxides that will be formed. Why? Because in EO2, here the oxidation state it is of +4 and here the oxidation state is of +6. And we know that +4 and +6 are the most common oxidation states, right? So those common oxidation states, oxides will be formed over here. Now let us talk about the dioxides. Okay, let us talk about the dioxides. So when we are talking about the dioxides, for example, in SO2, SeO2 and your TeO2 is formed. Okay, so we are forming dioxides like this. SO2, SeO2 and TeO2. Now can anybody tell me which is a good reducing agent over here and which is a good strong oxidizing agent over here? So how do we do that? So I told you that from sulfur to tellurium, what is happening? From sulfur to tellurium, what is happening? In sulfur, the most stable oxidation state will be +6 and tellurium, the most stable oxidation state will be +4, right? Why? Because as we go down, stability of lower oxidation state increases. Now tell me, what is the oxidation state of sulfur over here? It is +4, isn't it? It is +4, this is again +4 and this is again +4 oxidation state. Everything is in +4 oxidation state over here, every element. Now, sulfur is not stable in +4 oxidation state. It will want to convert into +6 oxidation state, isn't it? So what is happening to sulfur? It is getting oxidized, correct? So when sulfur is itself getting oxidized to convert into +6, it means it is behaving as a very, very good reducing agent. So bacha, SO2 is a very, very good reducing agent. Remember this thing. And Te, what is happening to Te, bacha? Once again. So bacha, Te here, what will happen to Te? This Te will want to convert into +2 oxidation state. Because it will want even to go even lower oxidation state. So because it wants to convert into even lower oxidation state, what will happen? It will act as a very, very good oxidizing agent. Remember this thing. So SO2 is a very good reducing agent, while TeO2 is a very, very good oxidizing agent. Everybody understood this? Now we'll talk about the trioxides in the next thing. Okay? We'll talk about the trioxides. Hi Veshu. Bye Veshu. Okay, next is, we're going to talk about the trioxides. Trioxides. Okay? Now in trioxides, I'm going to talk about what kind of trioxides can form. It can form SO3 and SeO3 and then your TeO3. What cannot form trioxide? Oxygen. Oxygen cannot form trioxide. Correct? Oxygen can only form ozone molecule, which is actually a dioxide of oxygen, isn't it? So oxygen cannot form trioxides while the rest of the elements can form trioxides like this. And bacha, remember, both dioxides, and trioxides, both dioxides and trioxides are acidic in nature. All these oxides that we've studied are all acidic oxides. Okay? Everybody understood this point? So this is about the reactivity with oxygen. What did we study? That it will form two kinds of oxides, dioxides and trioxides. Oxygen will not form trioxide. Both kinds of oxides will be acidic in nature. And then I told you which one will be the reducing agent and which one will be the oxidizing agent. So SO2 is a good reducing agent and TO2 will act as a good oxidizing agent, and the reasons I have told you abhi. Okay? Now the last reactions of the group 16, we are towards the last of the reactions. Reactivity with halogens. Okay? So what kind of halides can it form? But it can form variety of halides. For example, EX6 halide, in which it will have the oxidation state of +6. Correct? Okay, I will write the oxidation state with some other pen. Let's not write it with yellow color. Let me first let you know what kind of halides it from. EX6 kind of halide. Okay, the next is EX4 kind of halide, and the next is your EX2 kind of halide. Okay, and sometimes it will also form monohalide, but in what case I will let you know. Okay, so in EX6 it is showing +6 oxidation state, it is showing +4, and it is showing +2. So all these oxidation states are shown by your group 16 elements when they are reacting with halides. Okay, anybody has any doubt in it? Now let's talk about first of all the stability order, the stability of halides. Okay, so which halides are more stable, bacha? So bacha, fluorides are actually more stable than your chlorides, then your bromides, and then your iodides. Remember this order. All the fluorides are more stable than chlorides, bromides, and iodides. Okay, now one by one we're going to talk about everything. Now we're going to talk about first of all hexahalides. EX6 are called what? These are called hexa. Can you see? 6 halogen atoms are attached. Hence it is called a hexahalide. Correct? These are called hexahalides. And what is happening to these hexahalides? We're going to talk about first of all that only hexahalide that is stable is actually the EF6 halide. Remember this. Only EF6 are stable hexahalides. Hexahalides. Okay? Only hexafluorides are stable. Everybody understood this? Okay? Now next is bacha all EX6. All EX6. What is their structure? What will be the structure of these halides? These will be octahedral in structure. Octahedral. Octahedral means what? Here will be the element and all the 6 kind of halides will be arranged like this. X, 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 X. So octahedral will be their shape, and bacha, all the hexahalides are also gaseous in nature. Remember this thing. They're all gaseous in nature. Okay? And another thing that you should know about hexahalides is about SF6 molecule. Okay? Sorry. Let me drink some water. What is happening in the SF6 molecule, bacha? The SF6 is the most stable molecule. Remember this thing. SF6 is exceptionally stable. Exceptionally stable due to steric reasons. Due to what? Due to steric reasons. Okay? Because in the middle there is sulfur molecule and the outside there are 6 fluorine atoms arranged. I just told you that only the hexafluorides are stable. And which one is the most stable hexafluoride? It is SF6. Why? Because due to steric means due to their arrangement. Due to the arrangement of the atoms, the SF6 is very, very stable halide. Okay, we talked about the EX6 kind of halides. Now, we talked about EX6. Now, we're going to talk about EX4. Correct? Now, we're going to talk about, bacha, EX4 kind of halide. Okay, remember this thing. Remember this thing ki bacha, SF4, SEF4 and your TEF4. All these kinds of tetrafluorides. Your SF4 is actually a gas, your SEF4 is actually a liquid, and your TEF4 is actually a solid tetrafluoride. And what is their geometry? All of them will be sp3d hybridized. Remember this thing. What is the structure of sp3d, bacha? The structure will be trigonal bipyramidal, isn't it? Where we study this? We study this in chemical bonding, correct? The structure will be trigonal bipyramidal. Okay? And the major important thing, for example, let me show you the structure of SF4. So the structure of SF4, bacha, is in the center there will be the sulfur atom. Okay? Now there are 4 fluorine atoms attached. How will I attach them? See, this is a structure of a trigonal bipyramidal structure, isn't it? This is the shape of the trigonal bipyramidal structure. Now what will happen? I will attach 1 fluorine atom over here, 1 fluorine atom over here, and 2 fluorine atoms over here. Remember this thing. Here what is happening? Here there is a presence of a lone pair of electrons. So can you see here that the lone pair of electrons in this structure actually comes where, bacha? Are actually coming at the equatorial position. So lone pair are at the equatorial position. Remember this thing. Lone pairs are at the equatorial position. What is the equatorial? The triangle that is forming, right? Let me just show you here. Let me just show you with another pen. So these 3 bonds, bacha, are your equatorial bonds. Okay? The red colored bonds are your equatorial bonds. Correct? Equatorial bonds are equatorial position. Similarly, your green color bonds over here, your green color bonds are your axial bonds. And always remember one thing, that whenever there is a competition between any element and lone pair to take a position, then always remember that the lone pair will always first come on to the equatorial position. Always remember this. So whenever you have a, you do not know that where to put the lone pair, ma'am, we just have 1 lone pair, where to put it, then always put it at any of the equatorial position. That is only the correct structure, no matter the molecule. Here I am talking about SF4, right? So it can be another molecule. Hence, the geometry is trigonal pyramidal, but its shape will be called a seesaw shape. Remember this thing. The shape is called, bacha, what? The shape is called yes, bacha, to attain less repulsion. You're extremely correct about it. Why is Vaishu crying, bacha? Why are you crying? Why are you crying? This is not the moment to cry. Abhi, you have enough time to prepare. Do not cry right now. Okay? Everybody understood this? Now let's move on to the next thing. Next, we talked about the tetrahalides. Now we're going to talk about the dihalides, which is the EX2 kind of halide. So in EX2, bacha, what happens? All except, all elements, all except oxygen, they form, bacha, your dichlorides and dibromides. Remember this thing. Dichlorides and dibromides. Remember this thing. All except oxygen form dichlorides and dibromides. Okay? And what will be the structure, bacha? For example, if I'm trying to form SbR2. If I'm trying to form SbR2, what will be the structure? The sulfur will be sulfur here, Br here, Br here, right? And bacha, there are 2 lone pair of electrons. Can you see? 1 lone pair of electron, and there will be another lone pair of electrons somewhere another place. So it's actually, the structure is actually, one second. I will draw it here. Okay. So what is the hybridization of sulfur? It is actually sp3 hybridized, and we know what is the geometry of sp3 hybridized sp3 hybridized element. It is actually a tetrahedral geometry. Tetrahedral geometry, right? But its shape is actually a bent shape molecule. Can everybody see? The shape is bent shape. I understand this, but the geometry is tetrahedral. Okay? Next, reactivity towards halogens, we've already studied. Now, next is your monohalides, EX kind, which is called what? Monohalides. We talked about every kind of halide. Here, the oxidation state is +1, right? In the dihalides, the oxidation state was +2 of the element, right? In The monohalides, what happened, bacha? What happened in monohalides? The monohalides, usually they do not form. What do? Monohalides actually form dimers of themselves. So they exist in dimeric form. For example, let me tell you the example. For example, sulfur exists as S2F2 monohalide, or your S2Cl2, or your S2Br2. Similarly, what happens with selenium? Selenium exists as selenium dichloride and your selenium bromide, like this. So they form, bacha, they are forming dimers with each other. Remember this thing. The monohalides in group 16 actually exist in dimeric form. Okay? Now in dimeric form, bacha, what is the oxidation state of these dimers? For example, I am writing it here. The dimers, the dimeric halides, I am writing it here. The dimeric halides undergo disproportionation reaction. Disproportionation reaction. And you all must understand what is disproportionation reaction once again. What is disproportionation, bacha? What is disproportion? For example, for any element to show disproportionation, that element must have at least 3 kinds of oxidation state. Minimum 3. Maximum can be 5, 6, 7, anything. What do I mean by disproportionation? For example, I wrote here Se2Cl2. What is the oxidation? Acha, and what is oxidation? And through this, after disproportionation, what is forming? It is forming SeCl4 plus your 3Se. Okay? Now I will just change the pen color so that you can understand it extremely clearly. What is the oxidation state of selenium here? It is in +1 oxidation state. Here selenium is in +4 oxidation state, and here selenium is in 0 oxidation state. So can everybody see? From +1, this selenium is getting oxidized. Can you see? The +1 selenium is getting oxidized into +4 state, and similarly the same selenium is actually getting from +1 to 0, is actually getting reduced to 0 oxidation state. So can you see that the dimeric halide, the same selenium is showing both oxidation and reduction reaction in the same reaction, right? It is showing both oxidation and reduction in the same reaction. Such reactions are called disproportionation reaction, because in here we utilize 3 kinds of oxidation. So can you see, we started with +1 and now we have +4 and 0. So 3 kinds of oxidation states are involved in disproportionation reaction, and your dimeric halides actually undergo disproportionation reactions. Is this thing clear to everybody? Till now we've completed all the reactions of your group 16 elements. Okay? Now some more basic things. Ma'am, it is in introduction of P block. Yes, bacha, it is in introduction of P block. That is true. Okay? Next is, we've completed the reaction with halogens as well. Next thing that I'm going to talk about is dioxygen. Okay, it is again very, very important. Dioxygen is actually a colorless, odorless gas which is present in the atmosphere. What is that? Oxygen. What you're breathing in? Oxygen, right? So what is the structure of dioxygen? You must know. This is the structure of dioxygen, right? And it has 2 lone pair of electrons on both of the oxygen. Please remember. So in your reduced syllabus, what has happened? Only the trends and the reactions with hydrogen, halogens and oxygen is there now in a syllabus. And the compounds of the elements is no longer there. Okay? So they will no longer ask you any questions from the compounds of group 16, group 14, group 13, whatever group. Compounds are absolutely eliminated. But what you must know the structures of these compounds, because they have the high probability of getting asked, because they are there in your NCERT. So do not study the preparation, do not study the compounds, do not study the reactions involved of the compounds, but study their structures. Okay? So this is the first structure of oxygen that I discussed. Now we are going to discuss the oxides once again. So I told you what is happening. We're talking about this oxygen over here, right? We're talking about this oxygen. What this oxygen do? It is a highly reactive element. It forms oxides with everything, right? With this, every element. With every element, this oxygen reacts. So this oxygen reacts with everything. with the S block elements, with the D block elements, with even the P block elements, right? So oxygen is forming oxides with both non-metals plus metals, isn't it? Isn't it? So oxygen is forming oxides with both non-metals and metals, which is a highly reactive element. So we're going to study little bit more about these oxides, okay? Little bit more that how many kinds of oxides are there. I just told you that oxygen can react with any element, है ना? So now because it can react with any element, it has the ability to form various kinds of oxides. And these are actually simplified into two categories. One is the simple oxide and the other one is the mixed oxide. So, bacha, what is a simple oxide? Simple oxide, for example, your magnesium, MgO, magnesium oxide, or your Al2O3 oxide are actually called your simple oxide. Okay? Simple oxide, which means they are just made of these elements, that is it. But what happens with mixed oxides? Mixed oxides, for example, the very first example I'm going to tell you about is Pb3O4. But a Pb3O4 is actually not a single oxide, it is a mixture of, what it is? It is a mixture of two kinds of oxides, which is PbO plus PbO2. Similarly, what other oxides? Example of mixed oxides is Fe3O4. Fe3O4 is again a mixture of two kinds of oxides, your FeO plus your Fe2O3. Okay? So that is why it is a mixed oxide. Similarly, the next kind of oxide is FeCr2O4. Okay? This is again, bacha, a mixture of two kinds of oxide, which is FeO plus your Cr2O3 oxides. So whenever an oxide is actually a mixture of various kinds of oxide, it is called a mixed oxide. If it is present alone, solo, then it is called a simple oxide. Okay? So this is the first criteria to divide or to categorize these kinds of oxides. The next thing that we're going to study is these oxides, these simple oxides. Remember, what kind of oxides? The simple oxides are again categorized into four groups. Number one is acidic oxide, then basic oxide, then amphoteric oxide, and the fourth is the neutral oxide. In four categories we're going to study. What is acidic oxide? So whenever I have an oxide, okay, if I dissolve it in water, if I have any oxide, for example, here I will write, for example, if I have any acidic oxide, means what? Whenever I dissolve it in water, H2O, what will happen? I will get a acidic solution. Okay? If I get an acidic solution, then those are acidic oxides. Simple सी बात है ना? ठीक है? And what are the example of acidic oxides? Bacha, the examples are mostly, for example, your SO2 oxide, your Cl2O7, your chlorine oxide, right? Your carbon dioxide and your N2O5 oxide are all your acidic oxide. For example, if I dissolve SO2 in water, I will actually get an acidic solution of H2SO3. Okay? Now this is an acidic solution that I'm getting. Hence SO2 is a acidic oxide. Okay? Now bacha, what is the, ma'am, how will I know which will form the acidic oxide and which one will form the basic oxide? So bacha, in general rule, so I'm writing a general funda here. The general rule of for acidic oxide is that your non-metals generally form acidic oxides. Remember this thing. Generally form acidic oxides. Similarly, when the metals are in higher oxidation state, what I'm saying, but also this is the number one rule. The number two is when the metals are in higher oxidation state. Metals in higher oxidation state means what? They also form, bacha, acidic oxide. What are the examples of this? See, I'm going to let you know the examples as well. For example, I'm talking about Mn2O7 or your CrO3 or your V2O5. Okay? I've mentioned here three kinds of oxides of metals, right? These are all D block elements, and we know all the D block elements are metals. But can you see here manganese is in what oxidation state? It is in +7 oxidation state. Chromium here is in +6 oxidation state. Vanadium here is in +5 oxidation state. Can you see? So these are in very, very high oxidation states. Hence, all of these are actually acidic oxides. So what is the general funda? That all the non-metals will generally form acidic oxides. But sometimes when the metals are in higher oxidation states, then those oxides are also acidic oxides, and the examples are here written. Very, very important. These are very important notes. Please download them after the session is over from the Telegram channel. Nobody is going to uh, put so much efforts just to give you these notes. Correct? Nobody is going to teach you in so much detail. I've seen lectures on 16, 17, 18. They are actually very rare, first of all. And nobody teaches every line from NCERT and every funda that can be taught from the PYQs, right? Nobody does that. Okay? This is the first time happening on YouTube. I can say that very legitimately. Okay? Legitimately. Next is basic oxides. What are basic oxides? Again, when I put them in water, what do I get? If I put them in water and I get a basic solution, then those are basic oxides. And what are the examples of them? For example, what are the examples of them? For example, your your Na2O or your CaO, right? Your calcium oxide or your barium oxide, right? So these are all your basic oxide. For example, if I put calcium oxide in water, what will I get? I will actually get a calcium hydroxide solution, right? Which is a basic solution. Hence, calcium oxide is a basic oxide. And what is the general rule for basic? General rule I'm writing over here. General rule for basic oxide is all the metals will generally form basic oxides, right? Metallic oxides. All the metals generally form, bacha, basic oxides. Remember this thing. ठीक है? ठीक है? Basic oxide, that's clear. Now next is the amphoteric oxide. What is meant by amphoteric? Amphoteric, which means what? Which react with both acids plus base, right? These are called amphoteric, which have the capability to react both with acid and a base, are called amphoteric oxides. And mostly, bacha, these are metals. Okay, so some metals, what do? They perform the dual character. Okay, dual character means what? That they will react with both acids and base. Correct? And these are, and most famous example of amphoteric oxide is Al2O3 oxide. Now look at this reaction given in your NCERT. I've attached a snip over here. Every reaction given in your NCERT is very, very important, especially the reactions mentioned over here in these notes. Very important. For example, Al2O3, if I try to react it with acid, what is happening? A complex of aluminium and water is formed. And similarly, if I try to react the same with base, again a reaction is happening and again a complex is formed. Can everybody see? So Al2O3 is reacting with both acid and base, hence it is an amphoteric oxide. Okay, this is the third kind of oxide. Now we're going to talk about, no, bacha, this is not deleted. This is not deleted. Please do not get confused. See, in your course, it is mentioned that reactions with oxygen, hydrogen, and halogen will be asked. And what are we reading about right now? We're reading about oxides, which is again a reaction with oxygen. Hence, please do not do the blunder of not including these in your preparation. That's why whatever I'm teaching you are the things that are going to be asked in your exam for sure. Okay? Now next is neutral oxide. Okay? Neutral oxide means what, bacha? Which are neither acidic and nor basic. Correct? These are neither acidic nor basic. Which means what? They react with neither the acid nor with the base. What are the examples of neutral oxides? The examples of neutral oxide are carbon monoxide, or your nitrogen monoxide, or even your N2O oxide. Okay? So these are the examples of your neutral oxides. Okay? No, bacha, this is not. Yes, bacha, JEE aspirants can watch this because Neet and JEE both have the same course. I teach the same syllabus for both the students. The only thing that I skip is that in JEE, I use the JEE PYQs because right now we are focusing on the NEET on this channel. We focus on NEET, right? So I include the NEET PYQs. That is it. So after my lecture, you can go and solve your JEE PYQs if you are preparing for your JEE exam. Okay? Okay, everybody is clear about the oxides. The next thing is again, ozone is a compound of oxygen given in your syllabus. But as compounds are deleted, we're not going to study anything about ozone except its structure. First of all, some of the minute things that you should know, even though it's deleted, but can be asked because it is again a reaction of oxygen with oxygen. So it can be asked. For example, it is an allotropic form of oxygen. Allotropic means what? Another physical form of oxygen. Correct? And ozone does what? It protects you from your UV radiations that are coming from the sun. Very important. We've been reading it since about the 5th standard, right? Ozone. For example, this is the layer of ozone given over here. What does ozone do, bacha? Ozone absorbs the UV radiations coming from the sun. Where is ozone? Because bacha, ozone is a very, understand this, ozone is a very reactive molecule, right? So it is not present near the sea level. Okay? It is not present near the sea level. What happens? It is only present 20 kilometers above the sea level because it is highly reactive. Hence, on the sea level, it is never found. Okay, and this is the structure of ozone. Can you see these are the resonating structures of ozone? What is happening? The 3 oxygen atoms are present. With one, there is 1 pi bond and 2 sigma bonds present, right? And these many lone pair of electrons are also present. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So these kind of lone pair of electrons are also present. This oxygen has a positive charge on it. This oxygen has a negative charge. This oxygen has a negative charge, and this oxygen has a positive charge on it. So these are all their resonating structures. These structures are important, can be asked in exam, and have been asked. I will show you with the PYQs. Okay? The next thing is, I told you that ozone is very reactive. How it reacts with the oxygen? What does it do? It itself breaks down in the presence of light. What happens? It breaks down in the presence of light into oxygen and nascent oxygen. Nascent oxygen is very reactive oxygen. Okay? And due to this release of nascent oxygen, ozone is a strong oxidizing agent. Can you see that it is able to give away? Nascent means free oxygen molecule, right? Hence, it is a because it is giving away oxygen, hence it is a very good oxidizing agent. So these are the few things that you should know. It has a possibility of getting asked in exam, and I do not skip even one thing that can be asked. Now look at this question, look at this PYQ. As I told you that structure based questions are asked. Where is my mouse? Okay, it's here. Got it. AIPMT 2008 question. The angular shape of ozone, O3, consists of, what is the answer to this? What is the answer to this? The angular shape of ozone molecule consists of, I just told you, this is the ozone molecule, right? This was the ozone molecule. This is the angular shape of ozone molecule, right? Here, how many bonds does it have? It has 2 sigma bonds. Can everybody see? 1 sigma bond, 2 sigma bond, and 1 pi bond. So the answer is B, 2 sigma bonds and 1 pi bond. Easy question, AIPMT 2000. Such easy questions are asked from the structure. Correct? Next is sulfur allotropic forms. Even though you might feel, ma'am, this is deleted from the syllabus, but let us not take the risk. Let us not take the risk. From sulfur, allotropes is what? Again, a physical form of sulfur. It can be from the physical properties of sulfur. They can say that we didn't exclude the physical properties. Why haven't you read about allotropic forms? So please read about the allotropic forms of sulfur. Actually, bacha, sulfur is present in so many allotropes. Okay? But these two that are given on your screen, which is a rhombic sulfur and the monoclinic sulfur, are actually your stable allotropic forms. वैसे तो sulfur is formed in so many allotropes, but these two are the stable of them, rhombic and monoclinic. Rhombic is also called the alpha sulfur, and your monoclinic is also called the beta sulfur molecule. Rhombic sulfur is called the alpha sulfur, or it is also called the yellow rhombic sulfur, right? Because can you see, rhombic means it has a round like structure called alpha. Okay? So this is the thing that you should know. Okay? Next thing that you should know is, bacha, the sulfur. I told you sulfur is what, bacha? It is a polyatomic molecule. In the starting of the lecture, I taught you that it is present in the form of S8 molecules. For example, oxygen is present as O2 molecule in the air, right? Similarly, sulfur is present as S8 molecule. Okay? And these S8 molecules have several allotropic forms. Two of them are rhombic and monoclinic. And these rhombic and monoclinic are actually interconvertible to each other. What is happening? Your rhombic form of sulfur, remember this, the rhombic acid sulfur is stable at room temperature. Stable at room temperature. Monoclinic is not stable, but as you increase the temperature to more than, if you increase the temperature to more than 369 degree, it will get converted into monoclinic sulfur. Remember this. Okay? And as you decrease the temperature, it will again convert into rhombic. So these are interconvertible depending upon the temperature. Okay, everybody understood this? Now, bacha, something that I want to tell you about the sulfur structure is key. Okay, let's talk about here only. Both the rhombic and the monoclinic are formed with S8 molecules. Can you see? The molecular composition is S8. Okay? So, bacha, these S8 molecules are actually, these sulfur molecules are present in form of ring structure. Okay? These S8 forms are formed in, for example, look at this structure. Can you see this crown form? Can you see? Let me change the pen color once again. Can you see this crown form? So, bacha, this crown form is correct for both your rhombic and your monoclinic sulfur. Okay? So, in both the cases, the crown form of sulfur, which is also called the puckered ring is present. I just told you that sulfur is present as a S8 molecule, right? S8, how are these S8 sulfur atoms arranged? They are arranged in form of a puckered ring, mostly in the form of a crown form. Okay, so this is how the S8 molecules are arranged in a pucker ring in a crown form. Is this thing clear to everybody? Okay, but bacha, what has happened? This S8 is present naturally, right? S8 molecules are present naturally, but scientists in the laboratory have been able to synthesize even S6 to S20 molecules. S6 to S20 molecules have been synthesized in the laboratory, right? And how are the S6 molecules arranged in the chair form? Can everybody see? The S6 molecules which is synthesized in the lab by the scientist, not found naturally. Naturally only S8 is found. Okay? But S6 to S20 have been synthesized, and the structure of S6 is a chair form. One thing to remember. The next thing to remember is, bacha, at elevated temperatures, very, very important point. When the temperature exceeds 1000 Kelvin, what happens? When the temperature exceeds 1000 Kelvin, the S2, like how O2 is present, similarly S2 is also present. So, bacha, the S2 is the most stable form at more than 1000 kelvins of temperature, and that is paramagnetic, just like the O2 molecule. So, bacha, your S2 molecule is actually paramagnetic in nature. Why? Because two electrons are present in the pi star anti-bonding orbital. Okay? Anti-bonding orbital. Two electrons are present, and two what kind of electrons? Unpaired. Unpaired also, I am writing it here. So, two unpaired electrons are present in the pi star antibonding orbitals. Hence, your S2 is a paramagnetic structure. S2 is, again, I am going to tell you, it is a gas, just like your oxygen. So, S2 is a gas which is most stable form of sulfur at higher temperature. Anybody ask you which is the most stable form at higher temperature? It is S2 molecule, correct? Which is paramagnetic in nature. These are all your facts from the NCERT. Do not skip those facts. Okay? So I think till here we have completed the entire NCERT. The again important reaction from your NCERT is this, which I have included over here. This is again given in your inorganic practical chemistry book, which is extremely important. In your inorganic practical chemistry book, you will again read about this reaction, which is a test for the SO2 gas. Okay? So I'm not going to explain it to you here right now. I'm just showing you that in P block certain reactions are repeated in the inorganic chemistry practical book. So do not forget to go through that book after you have completed the P block. Okay? So this is an important reaction. The screenshot of attached, you will get it in the PDF that I'm going to share with you. Okay, next thing that we will study about the oxoacid of sulfur. Do not make the mistake of skipping this point. Do not make the mistake of skipping oxoacids of sulfur. I'm again and again telling you. Good afternoon, Kiamat. Beta, this is not deleted syllabus. Do not make the mistake of considering oxoacid of sulfur as deleted, because the sulfur here, the sulfur, oxide of sulfur is what? It is a compound of sulfur with hydrogen and oxygen. And reaction with hydrogen and oxygen is in your syllabus. Okay? And why am I saying that with so much confidence? Because I've seen the paper this year of January, JEE January attempt. Hai na? I've seen the paper of JE, right? And for the JE students also the same reduced syllabus is applied. But in them, these structures were asked, oxoacids were asked. Okay, so I have another evidence to support that oxoacids have higher probability of getting asked in your in your NEET exam, not PMT anymore, right? In your NEET exam. So please, please, please do not forget to. Okay? So oxoacids, number first. Oxoacids are what? With sulfur, I'm reacting with hydrogen and oxygen. Various kinds of oxoacids are possible. First is your sulfurous acid. Okay? Sulfurous acid has a structure of just like this. How to draw these? So first of all, with sulfur, I have drawn one double bond O molecule. Similarly, okay? And here one OH molecule will be there, the other OH molecule, and here will be the lone pair of electrons. So this is how the structure will be drawn. Now you have to know what is their acidity and basicity. So here, because 2 OH is present, can everybody see? 2 OH is directly attached to the sulfur, hence its basicity will be 2. Can everybody see? Basicity means what? Basicity means that it can give away 2 H plus ions, correct? So that because it can give away 2 H plus ions, its basicity is actually 2. Ma'am, P block में तो introduction पूरेगा. What are you saying, Kaimat? I cannot understand you. I cannot understand you. Please let me know once again. Similarly, what is the structure of sulfuric acid? So, bacha, in this you have to know the name, okay, the formula, as well as the oxidation state. The structures are not hard to draw. They're very, very easy. If you draw it just like once or twice or thrice, then you're never going to forget these structures. Okay? And here again in H2SO4, again there are 2 OH present, hence the basicity is 2. In thiosulfuric acid, the structure is H2S2O3. The 2 sulfurs are connected through a double bond, right? And they have 2 kinds of oxidation state. Number 1 is +6. Now I'm going to teach you a very trick. This is not the method. I'm again telling you this is a trick. What I'm telling you right now is the trick to calculate 2 different kinds of oxidation state. Ma'am, how to know that these 2 sulfurs have different oxidation states? So this is a trick, not the actual method. This just applies to this area only. Do not try to apply to any other area, otherwise your answer will be wrong. So here, look at this sulfur. To how many atoms it is attached? It is attached to 1. How many bonds it is forming? It is forming 1 bond, 2 bond, 3 bond, 4 bond, 5 and 6 bonds. 6 bonds it is forming, so this sulfur is in +6 oxidation state. Similarly, this sulfur is attached to 2 atoms, right? So this sulfur is in +2 oxidation state because it is forming 2 bonds. Okay, so this is how you are going to tell. Actually, that is -2 oxidation state. Sorry, just write it as -2. Once again, -2 oxidation state. Okay, this is -2, this is +6 oxidation state. Okay, the next is again your H2SO5, peroxo monosulfuric acid. The common name is Caro's acid, very, very important. Here the oxidation state is again +6. In peroxo means what? Peroxo always means that one oxygen will be there in the middle, just like this. This is the meaning of peroxo. Again, the basicity is the number of OH group attached to, so the basicity is 2. Next is peroxo disulfuric acid. Again, 2 kinds of sulfur are present, but here both the sulfurs are in +6 oxidation states. Peroxo, again 2 oxygen groups are present over here. Here 2 OH groups are present, hence the basicity is again 2. What is the basicity, bacha? Basicity is again 2. If nobody can see it, please see it over here. Now the dithionic acid. Dithionic acid, both sulfurs are in +5 oxidation state. Here again 2 OH are present, hence the basicity is again bacha 2 basicity is there. Okay, everybody is understanding this. Now next is the pyrosulfuric acid. We're talking about the pyrosulfuric acid. So here what is happening? Pyro means again one oxygen is there in the middle. Both the sulfurs are in +6 oxidation state. And because two OH groups are present, the basicity again is just 2. Okay? Now we are going to do, now from my side, group 16 is complete. Nothing is going to come out of this. These notes are enough. You do not have to go through NCERT once again. I promise you this. Even if you do not study the NCERT now, just go through my notes and just go through this video, because right now we have covered all the PYQs ever possible and the NCERT and the periphery part. So I don't think there is any logical reason to go through NCERT once again. Okay, now let's look at this PYQ of NEET 2023. Who is going to answer this question for me? This is a match the following. See again, the questions on structures of the oxoacids are so frequent. I'm going to let you know. See, this is again oxoacids of sulfur are ours, and what kind of bonding is present in them, that is ours. Okay, we're not going to solve this again and again because I just told you these structures. So what you can do, you can just go through these after you have learned these structures, and again go through these PYQs and try to solve them, because there's nothing new for me to tell because I've already discussed all the structures. So you just have to match. Can you see one question again, 2023, last year only oxoacid question was asked. Now look at this NEET 2020 question. Again, which of the following oxoacid of sulfur has a OO linkage? Okay, I already told you which one has a OO linkage, which is a peroxodisulfuric acid, right? Which one has a OO linkage? Is nitrogen family for NEET? Yes, bacha, nitrogen family is coming. Who told you it is not coming? Nitrogen family is coming. And we've already done the nitrogen family, correct? Okay? So again, in which structure OO linkage is there? You again have to answer this question, correct? Now next is, in which pair of ions both the species contain a S single bond S bond? Okay? So you should know the structures of all these three. I've attached the structures of all these three, bacha. You can go through these structures once again. Once again, you can go through these structures. Okay? I've attached, and you can see where the S single bond S bond is present. So I think in the S4O6 again SS bond is there, and also in S2O3, even though there is S double bond S, but these two seem to be the correct answer. So S4O6 2 minus and S2O3 2 minus seem to be the right answer to me. So this seems to be the correct answer, right? Somebody is asking me, ma'am, last lecture notes. Beta, they are attached to, if you go and check the Telegram channel, they are posted there today only, and you can check under the video, the notes might be posted. Otherwise, along with these notes, if they're not posted yet, I will just go and see. Along with these notes, I will send the previous lecture notes. Okay, Karthik? Okay? Now next is the APMT 2015 question. 2015 question. The question asks, this is actually from the periodic properties chapter, right, which is in your 11th standard, right? So, but because this is an oxygen based question, so I've included it here. So the question is, the formation of the oxide O2 minus from the oxygen requires first an exothermic, this is exothermic, and then an endothermic step as shown below. What it is saying, you have an oxygen atom, okay? And to this oxygen atom, you want to make a O2 minus. So how will you make? First of all, you will attack one electron, right? So plus one electron you will do. Then again you will do plus one more electron, right? If you do two more electrons, then it will become a 2 negative species, just like this. Correct? So that's how it will get a O2 minus species. So what it is saying, the addition of first electron is a exothermic process. But the addition of the another electron is actually an endothermic. Exothermic means what? When I attack one electron, the energy is released. But to attack the another electron, I have to give it energy, right? I have to give it energy. And why is that the case? Why is that? It is due to the fact that, why does it happen? Why does it happen? So, bacha, it happens because oxygen is a very chotu molecule. It is a very, very small molecule, right? So, because it is a small molecule, after addition of one electron, what happens? If you try to attack another electron, one electron is already more in there. Okay? Now, you are trying to attack one more electron, so there will be so much more repulsion, right? So the correct option is electronic repulsion outweighs the stability gained by achieving noble gas configuration, and hence what happens, the addition of another electron is actually a endothermic process, not an exothermic. You have to give energy to attack another electron. Next is your APMT 2015 question. Once again, which of the following statement given below is incorrect? Which is the incorrect statement? This is from the group 16 once again. Is ozone a bent molecule? Yes, this is a bent molecule. Is ONF isoelectronic with N2O? So what is the structure of ONF? Who can draw? ONF means what? Nitrogen will be in the center because the most electropositive or the least electronegative atom gets the center. Nitrogen seems to be the least electronegative among oxygen and fluorine, right? So it will form double bonds with oxygen and single bond with fluorine, right? And similarly, what is the structure of NO2? The structure of NO2 is N double bond O, and here it is O, right? So let's count the number of electrons on each of these species. If you count the number of electrons, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6, right? If you count the number of electrons, these are actually isoelectronic species, right? So this is actually true statement. Again, OF2 is an oxide of fluorine. Is this the correct statement? OF2 is an oxide of fluorine. This is a false statement. Why? Because between oxygen and fluorine, fluorine is a more electronegative element. Hence, the compound formed with oxygen and fluorine is not called the oxide of fluorine. Rather, it is called the oxygen fluoride. What it is called? It is called oxygen fluoride. Remember this thing is called oxygen fluoride. So this is a false statement. So we know that C is the incorrect option over here. Okay? Everybody understood this? Next is again your question on the screen. AIPMT 2005 question. See, we are doing more than 15 years of PYQs here. I have included every possible PYQ that I can get on the internet, outside the internet. Every PYQ is here. What is the correct relationship between the pH of isomolar solutions of sodium oxide? Sodium oxide has a pH 1. Sodium sulfide has a pH 2. Sodium selenite, this is selenite, has a pH 3. And sodium telluride has a pH 4. Okay, you have to tell me the relationship of the pH. What they have given you Na2O. They have given you Na2S, they have given you Na2SC, and they have given you Na2TE. Okay? And they are asking you about the pH. The number one thing that you should know is that again pH, just like pKa. pH is what? Ki more the acidity, lesser will be the pH. Correct? So pH is again inversely proportional to the acidity. Now among these molecules, oxygen, sulfur, selenium and tellurium, what is happening? I told you. As I'm moving down the group, what is happening? The metallic character is increasing, isn't it? Oxygen, bacha, is the most electronegative element, and here tellurium is the electropositive element, isn't it? So as I'm moving down the group, metallic character is increasing. Does everybody agrees to this, right? How will you see? This is a very beautiful question asked. So as I'm moving down the group, I know we just discussed that the metallic character actually increases in the group 16 as we go down the group. So when the metallic character is increasing, what the other thing that I discussed with you? The other thing that I discussed is that the metallic oxides are basic oxides and the non-metal oxides are acidic, right? I discussed, right? The non-metal oxides are actually acidic, right? More acidic in nature, and metallic oxides are basic in nature. We just discussed this. Hence, what will happen to the pH? First of all, I will write down the acidity order, then I will write down the pH order. Therefore, most non-metal is oxygen. Therefore, the Na2O will be the most acidic oxide. Then will be your Na2S. Then will be your Na2SC. Then will be your Na2TE. Tellurium. Now, what will be the pH? I told you. More acidic the oxide, lesser will be the pH, right? So lesser will be the pH order is Na2O will have the lowest pH, right? So pH 1 will be the lowest, huh? So pH 1, it had the pH 1 will be the lowest, then will be your pH 2, then will be your pH 3, and then will be your pH 4. So this is the order of the oxides. So I think the correct answer actually is number C, right? So pH 4 is because it is the most basic oxide. So most basic oxides have the highest pH. So this is the order, pH 1, pH 2, pH 3. Everybody understood? It's a very beautiful question. That's why I included this. You have to just use your brain. What is happening? The sodium is remaining same, ma'am. Only the anion part is changing. If the anion part is changing, I have to see the trend in the anion part. What is happening? As I'm going down the group, actually what is happening? The metallic character is decreasing, is increasing. Metallic character increasing, matlab ki basic nature of oxide will increase. है ना? Basic means most basic is the pH 14. So the pH is actually increasing as the basicity is increasing. So most basic is the tellurium, hence it will have the highest pH value. Very easy question, very extremely easy question. Okay. Now we come to the group 17. Group 17 we have completed. Group 13, group 14, group 15, group 16. Only two groups are left, 17 and 18 is a very small group. It will require like more, not even 15 minutes we will complete the 18 group. Okay. In 17th again we are going to take 1 hour, then 15 minutes for the 18th group, and this lecture will be over. Let me drink some water. Sorry, I've been speaking continuously since 2 hours. Let me know how is the preparation for NEET exam is going. Till then, whoever are watching, beta, for getting the notes, you can join the Telegram channel. The link is in the description box, first of all. And on the Telegram channel, every day the notes are uploaded and even more things are added, whichever are required for your NEET preparation, all the announcements and everything. You can join the channel. The next thing is, if you don't want to join and if you're unable to join, you don't have a Telegram account, then my first advice is please have a Telegram account, because so many notes are only shared on Telegram. Okay? The second is, you can, after the session is over, like today or tomorrow, the notes will be uploaded even below, even in the comment section I will upload the notes. Okay? Okay? Please let me know, whoever is watching, ki how is your NEET preparation going on? What are the things that you're lacking? Ki what do you think, ki ma'am, I am not getting access to this? How to prepare for that part? How to do this? But only related. Okay, ask me for any subject. That's okay. If you have any question, please let me know. Otherwise, we will start group 17. I've drank enough water. Ma'am, drop lena sahi hai. Beta, are you in 12th standard or what? Is this your first drop? Is this your first drop, Guria? From my experience, it is not at all okay to take a drop. Because in drop, no. Second drop, not at all. I will never recommend a second drop. First drop, maybe you can consider, because you have too many things going on. You even have 12th board exam, this and that, practicals. So you might get messed up in your preparation. But second drop is not at all recommended. That is okay. Please do not take a second drop. Abhi bhi bacha, you have 2 months na with you. Just utilize those 2 months with the absolute best. And my only advice is only do NCERT. No matter what happens. But what happens in chemistry, bacha? Exact question from the NCERT you will see in the exam. That has happened so many times. So please do not make the mistakes of not going through all the questions, all the examples of NCERT. So what I'm doing right now, because I am teaching you inorganic, so I'm including everything in the notes itself, because I know students just don't go through the NCERT. But for the other things, please go through the NCERT. Okay? Next is, chalo, let's start with the group 17 without wasting any more time. Group 17 is also called, bacha, the halogen group. Everybody is familiar with that, called the halogen group. What are the elements? Elements are fluorine, chlorine, bromine, iodine, and astatine. What is the electronic configuration? It is Ns2np5, right? They are just one electron away from gaining the noble gas configuration, right? Only one electron is less with them. Okay, very, very important thing. Now in group 17 is actually a very interesting group because the properties of all these elements down the group is very much similar. It means fluorine, chlorine, bromine, iodine have very similar properties. Okay? As compared to other elements in other groups. Like in group 16, the properties can be variable. But here the properties are very much similar down the group. They have great similarities in properties. Now let us look at their occurrences. Beta, I do not know Tamil. Okay, now let us look at the occurrences. Occurrences means what? How are they found? So fluorine and chlorine are fairly abundant. They're fairly abundant on your earth, but your bromine and iodine are less. Okay? And fluorine is mostly present as insoluble fluorides. For example, in fluorospar, in cryolite, in fluoroapatite. Also, another time I'm repeating that please go through these mineral names. Okay? Whatever are these present over here, you should know. What all should you know? You should know their chemical formula and their chemical name, because these are directly asked in your exams. Okay? Even this year in JEE, these simple things were asked. Seriously. Do not make the mistake of not knowing the formula and their chemical name. Okay? And they're also present in your soil, in river plants, in your bones also fluorine is present, in teeth of animals fluorine is present. Seawater contains what? The seawater contains chlorides, bromides and iodides. Remember this thing. Iodides of sodium, potassium, magnesium and calcium. Okay? Mainly what is present in seawater? Seawater, say you take out salt, right? So seawater mainly has NaCl in it, which is what? Chloride. Okay? Again, the next thing is in your seas, bacha, what is present in marine life? Iodine is present in the form of seaweeds. Okay? And also, for example, 0.5% of iodine is present in seaweed, and in chili salt petre contains 0.2% of sodium iodide. Also remember this thing. Okay? And also remember कि sodium chloride and carnallite has this formula. Okay, they also contain your chloride molecule. So this is like a abundance occurrences thing which you should know. Okay. Now let's talk about the atomic and ionic radii. Again, these have rarely any exceptions. We've seen the exceptional groups in 13 and 14 and 15, right? Here there are no exceptions. Again, as I'm going down the group in fluorine, what does it have? Fluorine have two valence shells, right? Similarly, your chlorine, what does chlorine have? Chlorine have 3 electron shells. Bromine have 4 electronic shells, right? So what is happening? As I'm going down the group, the shells, the number of shells are increasing. If the number of shells are increasing, it means the radii will also increase, right? So as I'm going down the group, the radii will increase. Hence, the trend is simple. Simple, it is fluorine is lesser than chlorine, then bromine, and then iodine. So this is the radii trend followed. Simple. Next is the ionization energy. And we know that as we go down the group, the size is increasing. And if the size increases, the ionization enthalpy decreases. So hence, again the order is same, that fluorine has the highest ionization energy, then chlorine, then bromine, and then your iodine, because smaller size atoms will have the highest ionization energy. The reasons I've already discussed so many times. Now is the electron gain enthalpy, which means what? How much is the ability to gain electron within the atom? Okay, it is accepting electrons. Okay, so always remember electron gain enthalpy is always negative value. Why is it a negative value? Because you are adding something in the atom. Therefore, a bond is forming, and whenever a bond is formed, energy is released. Hence, electron gain enthalpy is a negative value of energy. Okay, so the highest negative value is actually of chlorine, then your fluorine, then your bromine, and then your iodine. Can you see over here? कि fluorine actually has a lesser electron gain enthalpy, which means what? This is the fluorine atom, right? Fluorine atom already has 7 electrons in it. So to accept the 8th electron, what is happening? Because fluorine is a very chotu atom, very small atom. Hence the incoming electron will experience the most repulsion. Hence the addition is not that easy. Therefore, its electron gain enthalpy is less negative than chlorine. So the electron gain enthalpy order followed is actually this. Okay, everybody understood? Beta, enthalpy means energy. It is the another name for energy. So whenever a bond is formed, what happens? Energy is released. And released energy is always taken as a negative value. When you have to provide energy, For example, when you have to heat a substance, you are heating it with a candle or with a flame, right? When I'm heating it, I'm giving it energy. So when you're giving energy from outside, it is called a positive energy. But when sometimes what happens, the beaker, even without giving any energy, the beaker becomes warm on itself, right? So it means what? The beaker is releasing energy. So that energy which is released is taken as a negative. That generally happens when new bonds are formed. When new bonds or something is added to it, then a bond is formed, and that bond formation will release energy. Hence, that energy is negative value. And what is the trend? It is chlorine, then fluorine, then bromine, then iodine. Okay? Now, next is electron negativity. I keep on telling you the difference between electron gain enthalpy and electronegativity. Electron gain means it has already accepted the electron within its atom. Correct? Electronegativity means what? It is a tendency to just attract electrons. Okay? Electron gain, matlab it has gained the electron. It means it has married the electron and took it home. Electronegativity means what? It is just flirting with the electrons that are present. It is not marrying anybody there. So that's why electronegativity is different. So electronegativity value is, bacha, fluorine is the most electronegative element. Remember this, fluorine is the most electronegative element in periodic table. Remember this thing. Okay? Fluorine, then chlorine, then bromine, then iodine. Okay? This is the order for electronegativity. Everybody is understanding this? Okay? Now let's move on to the next thing, which is their physical properties. You have to know a lot of things about the physical properties also. What is happening in physical property, Vacha? What is happening in physical properties? For example, your fluorine and chlorine both are, bacha, gases. Remember this thing. Your fluorine and chlorine both are gases. Your bromine is a liquid, while your iodine is a solid. This is the first thing that you should know about the physical properties. Okay? The next thing that you should know is their enthalpy of dissociation. Okay? Have I included color anywhere? No. So I will also tell you their color. Okay? These also shows, bacha, color. Okay? For example, your F2. For example, bacha, your F2 is yellow in color. Remember this thing. These colors are given in NCERT, hence have the tendency to get asked. So please take notes of these. Then, for example, Cl2 has a greenish yellow color. Remember this thing. It has a greenish yellow color. Similarly, your bromine is red in color. Similarly, your I2, iodine, is actually violet in color. So these are the colors. These are some of the physical properties. That's fluorine and chlorine are gases. Bromine is a liquid. Iodine is a solid. And these are the colors of the rest of the compounds. Okay? Next is their bond enthalpy. Enthalpy of dissociation means what? For example, this is the fluorine-fluorine bond. So what is the energy required to break these bonds is called the enthalpy of dissociation. I want to break the bonds. Okay? So, bacha, enthalpy of dissociation actually follows this order. It is Cl2. Cl2 is the most, and then your Br2, and then your F2, and then your I2. Can you see? This is the enthalpy of dissociation trend according to your NCERT. It means what? It is the most difficult to break the Cl2 bond, then Br2, then F2, then I2. Can you see that F2 is an exception over here? F2, why is F2 an exception? Again, I told you, because fluorine-fluorine atoms are two smaller atoms and you're trying to make them come together because they're so small. They're highly electronegative. Hence, they also experience the most electronic repulsion. So, two fluorine molecules experience most electronic repulsion. Hence, they will readily separate. Correct? Their bonds are easier to break because they're already experiencing so much of electronic repulsion. Therefore, the enthalpy of dissociation of these bonds follow this order. Chlorine has the highest enthalpy, then bromine, then fluorine, and then your iodine. Okay? Next is your melting point, boiling point. It is easier. Melting point, bacha, follows this order, which is your, as the size increases, the boiling point also increases, or the melting point also increases. Same thing is happening here. As I'm going down the group, the size is increasing, and hence the melting point, boiling point. Fluorine, then chlorine, then bromine, and then your iodine. So this is the melting point, boiling point order. Next is your density. Again, same order. As I'm going down the group, the mass is increasing. If the mass is increasing, so will the density. Hence, fluorine is lesser dense than chlorine, then bromine, and then your iodine. So these are important trends according to your NCERT. You have to learn these trends, especially your enthalpy of dissociation. Questions from this are asked every year. Very, very important trend. Okay, now there's a very important question for you. Although electron gain enthalpy of fluorine, I just told you, electron gain enthalpy, which means the tendency to accept electron is less negative. Electron gain enthalpy order was chlorine, right? Chlorine and then your fluorine and then your bromine and then your iodine. This was the order. Is less negative compared to chlorine. Fluorine is still a stronger oxidizing agent. Why is fluorine even oxidizing agent? What is the electronic configuration of fluorine? Ns2np5, isn't it? Isn't it? Now to gain stable configuration, what does it need? Only addition of one electron, isn't it? If one electron is added to it, it will become Ns2np6. Addition of electron is called what? Addition of electron is called reduction. Hence, fluorine is itself going reduction. Hence, fluorine will act as a good oxidizing agent. This is the reason for why fluorine is oxidizing. Now, it is asking even though. So, what are we doing? We are adding one electron to fluorine, and that's why it is behaving as a good oxidizing agent, right? But the question is, the electron gain enthalpy, right? The electron gaining tendency is actually higher for chlorine, and still you are saying, ma'am, ki fluorine is a better oxidizing agent. Why is that the case? That is the case because of two reasons. Number first reason is because low enthalpy of dissociation of FF, right? I told you that it is very easier to break the FF bond. Number first reason. Number second reason is high hydration enthalpy. High hydration energy enthalpy is one and the same thing. High hydration enthalpy of F minus ion, because F minus is a very chotu ion, right? Very small ion. Hence these have the high hydration energy, and also because of low enthalpy, it is easier to break the FF bond. It means it has low dissociation energy. Because of these two reasons, it acts as a very, very strong oxidizing agent. What is the reason for oxidizing agent? I told you. And why fluorine is still a stronger oxidizing agent than chlorine? Because of this reason. Everybody understood? Everybody understood the reason? Okay? Next is oxidation state. Again, we've talked about the atomic properties, we've talked about the radius, ionization energy, electron gain enthalpy, electron negativity, all these orders we've already talked about. What now we are back to the chemical properties. So for discussing before the chemical properties, we must know what all oxidation states can it show. Okay? So bacha, it can show for first remember that all of the halogens can show -1 oxidation state. Remember this thing. Okay? All of them bacha can show -1 oxidation state. Okay? And with chlorine, bromine and iodine, again with these three elements, again they can also show +1, +3, +5 and +7 oxidation states. Okay? Along with -1, they will show -1. Yes, definitely. Fluorine only shows -1 oxidation state. Chlorine, bromine, iodine also show -1 oxidation state. But chlorine, bromine, iodine along with -1 will also show +1, +3, +5 and +7 oxidation states. Okay? Okay? Now, when they will show these higher oxidation states, bacha. So, bacha, higher oxidation states will be shown with more electronegative elements, just as oxygen and fluorine, right? Higher oxidation states will be shown with more electronegative elements like oxygen and fluorine. Okay? Okay? Now, the question should be, ma'am, why do they show so many oxidation states? So, let us look at, I'm drawing it here, I'm again writing there NS2, NP5, their electronic configuration. Okay? Now the number one thing to gain a noble gas configuration, what they can do, number first thing they can do is, if I add one electron to them, okay, if I add one electron to them, then they can get NH2NP6, which is the noble gas configuration. So if I'm adding one electron, it means it is showing the -1 oxidation state, correct? When you are adding an electron, you getting the -1 oxidation state. So when does it show +1, +3, +5, +7, ma'am? So look at their electronic configuration. This is the electronic configuration of NS2NP5, isn't it? This is the electronic configuration. Can you see that there is one unpaired electron? So this one unpaired electron shows +1 oxidation state or the -1 oxidation state. Correct? It can either accept or go away. Okay. Now in the first excited state, what is happening? Now this electron in the first excited state go over here. Okay. So now you have a total of 3 unpaired electrons. Correct? Now 3 unpaired electrons in the first excited state shows +3 oxidation state. Similarly, what can happen? This electron can again gain energy and go over here. So in the second excited state, there are actually 5 unpaired electrons. So these can show +5 oxidation state. Similarly, in the third oxidation state, there are actually 7 unpaired electrons. Hence, they can show +7 oxidation state. Here, there is just 1 electron. Okay? Remove all these electrons. This is just 1 electron. Hence, there are 7 unpaired electrons over here. Hence, it can show +7 oxidation state. So, this is how all these variety of oxidation states can be shown with the help of their electronic configuration. Is this thing clear to everybody? Now let us move to the next thing, oxidation state. Now I also told you that higher oxidation states are shown by oxygen and fluorine. Okay? When chlorine, bromine, iodine are attached to oxygen or fluorine, they will show the higher oxidation state. Okay? Now what does it mean? For example, these are already halogens. Hai So when I'm making interhalogen compounds, interhalogens means what? I'm reacting one halogen with the other halogens. Okay? So interhalogen compounds or their oxides or their oxoacids remember this. Okay? Oxides means whenever I'm trying to react it with just oxygen. Okay? Oxoacids means I'm trying to react with oxygen and hydrogen. Okay? Interhalogen means I'm reacting with another halogen. So you should know this. Oxide means when I try to react halogen with oxygen, it is called oxide. So when I try to react halogen with another oxygen and hydrogen together, they will form an oxoacid. Okay? Okay? Understood these things? So with these 3 kinds of compounds, it will show higher oxidation states. Higher oxidation states. Okay? For example, I'm again writing it here. For +4 and +6 oxidation states, you will show oxides and oxoacids. Oxides and oxoacids. Remember this thing. For +4 and +6 oxidation state, oxides and oxoacids will be shown with chlorine and bromine. Okay? Similarly, with fluorine, only -1 oxidation state will be shown. Okay? Everybody understood this? Okay? Next is, bacha, we're going to talk about its reactivity. Know that these are highly reactive compounds. These are highly reactive elements. Remember this thing. These are highly reactive elements. Okay? Bacha, what are you trying to ask about the class? I don't understand. These are, bacha, highly reactive elements. Okay? And the reactivity order is fluorine, then chlorine, then bromine, and then your iodine. So this is the reactivity order followed. Okay? This is the reactivity order followed. Okay? 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 Now they are, bacha, strongly oxidizing agent. Okay? They are, remember this thing. They are strong oxidizing agent. Why do I say this? I again told you, right? Look at their electronic configuration. It is NS2NP5. Correct? Now, as soon as they gain one more electron, what will happen? They are gaining electron, and as soon as they gain one more electron, they will become NS2NP6 kind of configuration, isn't it? Because they are becoming NS2NP6 kind of configuration by gaining one electron. So when I'm gaining electron, what am I doing? I am getting reduced If I'm getting reduced, then I'm acting as a very, very strong oxidizing agent. Hence, all of these, thorium, chlorine, bromine, iodine, are actually very, very good oxidizing agent. And I already told you that F2 is the strongest oxidizing agent among these. Strongest oxidizing agent among these. Correct? Correct, because bacha F2 has the capacity to oxidize. What can it oxidize? It has the capacity to oxidize even the halide ions. Oxidize other halide ions even in solid phase. Even in solid phase. What do I mean by that? Let us look at. What I am saying, even other halide ions, fluorine is able to oxidize them. Let us look at these reactions. Can everybody see this reaction on the screen? What is happening in this reaction, bacha? For example, fluorine is here. Now fluorine, I told you, it is the strongest oxidizing agent. It is able to oxidize other halide ions. So any halide can be present over here. The X can be chlorine, bromine or iodine. So fluorine is here. So any halide from the below can be there. So fluorine can actually oxidize the below halides. Oxidize means what? It itself gets reduced. Fluorine here was in zero oxidation state. Here it gets converted into -1. So what is happening to fluorine? It is getting reduced. It is itself getting reduced. Hence, fluorine is actually acting as a very, very strong oxidizing agent. And this X minus here, it was -1, and -1 gets converted into zero oxidation state. Correct? So what it is doing, fluorine is able to oxidize other halide ions. Similarly, chlorine will be able to oxidize bromine and iodine. Okay? Similarly, bromine will be able to oxidize iodine. So what is happening? The above halides can oxidize the below halide ions. Remember this thing. See, chlorine is able to oxidize the other halide, which is bromine or iodine. Similarly, bromine is able to oxidize the iodine ions. Okay? So remember this thing. The above halide can oxidize the below halide ions. Is this thing clear to everybody? Now next we're going to talk about the oxidizing power. Ma'am, you have told that all of these halogens are actually oxidizing agents. I understood why they are oxidizing, because they have a tendency to accept electrons, right? And you also talked about which is a very, very strong oxidizing agent. But how do we know about their oxidizing power? So bacha, oxidizing power actually depends on their standard reduction potential. Standard electrode, I'm writing over here. Standard electrode potential. Now, the next question should be, I'm telling you, the oxidizing power actually depends upon the standard electrode potential. Now, ma'am, what is electrode potential? But electrode potential can only and only be measured experimentally. What is happening? For example, I took a halide ion over here. Okay, I have a X2 gas, which is any halogen, for example, fluorine gas, chlorine gas, or whatever. So I took a halogen gas and then I tried to break it. For example, if I had a fluorine gas, I'm trying to break the FF bond. Okay, to break the FF bond, I need energy because you're breaking. So this energy is called the dissociation, because you're dissociating the element. So what did I do? I broke this element and I formed the simple alone atom, which is again in gaseous state. Now in gaseous state, what I want to do, I again want to give it one electron. So what did I give? I took the electron gain enthalpy and I gave it one electron. So I gave it one electron in the gaseous state. This is called the electron gain enthalpy. So after making an anion of it, after making a gaseous anion, I want to make it in a aqueous anion. I want to solubilize in water. So I took this gaseous anion and I put it in water. So when I put it in water, the energy released is called the hydration energy. So can you see? Can you see that all of these energies combined is called the electrode potential? All of these energies combined will decide the electrode potential of any element. What did I do? I had a gas. I had a fluorine gas. So this F2 molecule, I need to first cut it. Cut the bond between them. This is called a dissociation energy which is needed. Okay, then I have the single atom with me. To that single atom, I gave it one electron to make it an anion species. So after making it a gaseous anion, I want to dissolve the gaseous anion in water. So when I dissolve it in water, some energy will be released called the hydration energy. So on all these three kinds of energy, it can be electron gain or ionization energy. Okay, remember this thing. For more negative elements, it will be electron gain enthalpy. For positive elements, it will be the ionization energy. So all these three kinds of energy when added together will give you the standard electrode potential. All these three energies added together will give you the standard electrode potential, and on this potential oxidizing power actually depends. Okay? If question comes, this is how you're going to tell कि this is how the oxidizing power depends. Okay? Okay? Everybody understood? Everybody understood? What else are the things that I need to tell you about? Yes. For example, look at the oxidizing power over here. I told you that fluorine is a very good strong oxidizing agent. And it has the power to oxidize even water. Can you see? Fluorine, what is happening? Fluorine is in zero oxidation state, and here it is getting converted into -1. So can you see that fluorine is actually getting reduced? It means it is acting as an oxidizing agent. Similarly, it is oxidizing water. What is happening to water? The water has two hydrogen atoms attached. Can everybody see? Now, in the product, in the product, can everybody see from H2O, I'm getting an oxygen gas. Can you see that hydrogens are removed from here? And what is the other name of removing of hydrogen? Reduction, right? So here what is happening? Oxidation. Removal of hydrogen is oxidation. So here oxidation of water is happening. So can you see that fluorine is able to oxidize even water? Similarly, other halogens, for example, your chlorine and bromine also react with water to form a halo acid and a hypohalous acid. Okay? The next thing is if you try to react iodine with water, what I'm doing iodine with water. This reaction, bacha, does not happen. See, what I'm trying to do, I'm trying to react iodine with water, and this reaction does not happen, right? This reaction does not happen. It is actually a reversible reaction. So can you see iodine react with H plus and O2 to give I2 and H2O? These are important reactions. Understand this thing, can be asked in your exam. And also look at this iodine reaction and look at this fluorine wali reaction. You will see that the iodine is exactly the opposite of fluorine. So what is happening in fluorine? From F2 it is converting into F minus. Here in iodine from I minus it is getting converting into I2. So can you see? Ulta reaction is happening in both of these cases. Okay? So this is how you're going to study about the oxidizing power. I know that fluorine is the most strongest oxidizing agent, then chlorine, then bromine, and then iodine. Okay? Everybody understood this thing? Beta, which reaction are you talking about? Which is oxidizing it? Beta, which reaction, Gudiya? Can you ask me again? I just saw your question. Which reaction? Which reaction, Gudiya, are you asking me about? Which reaction, bacha? Which reaction? In previous, which reaction? Sorry, I did not get your question. Please write the correct question and then I'll answer to you. Till then, I'm going to move forward. Now, anomalous properties. As we've discussed, in every group, the first element will behave randomly, will behave anomalously. Okay? Will behave randomly. Why does it behave, bacha, fluorine? Bacha, first of all, because fluorine has a small size. Remember this thing. Fluorine has a small size, number first point. Second is, it has the highest electronegativity in the entire periodic table, right? Number third is, it has low FF bond dissociation energy, isn't it? It has low FF bond dissociation energy, correct? And the last point is, it has no d orbitals. So due to all these reasons, fluorine shows anomalous property, means its properties are different than the rest of the 17th group elements. Okay? Next is, most of the reactions of fluorine also understand what are those properties, anomalous properties. Those properties are most reactions of fluorine, bacha. Most reactions of fluorine, bacha, are exothermic in nature. Remember this thing. Most reactions of fluorine are exothermic, which means what? The energy is released. Why? Because fluorine is a smaller molecule, hence all the bonds formed will be smaller and hence the energy will be released. So most reactions of fluorine is exothermic because of its because it is small in nature, correct? And also, bacha, fluorine only forms one oxoacid. What is oxoacid? We're going to study later on, right now. Okay? And remember that fluorine only forms one kind of oxoacid. Oxoacid is anything in which I react fluorine with oxygen and hydrogen. Okay? So it only forms one kind of oxoacid. The other elements form various 3-4 kinds of oxoacids. Okay? This is the thing that you have to know about. Let me see if I'm yes, while others form. Okay? And the last thing that you should know is bacha, the HF molecule that we were talking about, the HF, the hydride of fluorine that we're going to form, bacha. The HF molecule is actually liquid in nature. Why? Again, due to H bonding. Due to H bonding, correct? It is liquid in nature, but the other He molecules, the other hydrogen acids are actually gaseous in nature. So these are the anomalous properties. Why fluorine behaves differently? I told you the reason. And what are the different properties that it shows? So first of all of its reactions are exothermic in nature because of its small size. Next thing is it only forms one kind of oxoacid, ma'am. The others form various kinds of oxoacid. The third is that the hydrogen acids that we are forming, the HF is actually liquid due to H bonding. The all others are actually gaseous in nature. Okay? This was the anomalous properties of fluorine that we talked about. Sorry, now we're going to talk about the reactivity with hydrogen. Now we have completed all the basic things. Now we are back to the reactions. First, we will see the reaction with hydrogen, then oxygen, and then halogens. Correct? We're talking about reactivity with hydrogen. What will it form with hydrogen? It will form a compound just like He kind of compound, isn't it? For example, it will form HF, it will form HCl. With hydrogen, it will form HBr. And with hydrogen, it will form HI. With astatine, we do not study because astatine is a radioactive element, correct? Okay. Next is HF, HCl, people are cricket world is saying, ma'am, you look like Billie Eilish. Is it so? Is it really so? Should I start singing now and just drop this career of teaching and I should start singing? What songs do you know of Billie Eilish? That you are writing Billie Eilish over here. ठीक है. Now we're talking about the reactivity towards hydrogen. Yeah, I should definitely start singing on this channel. Probably people will watch me more then, right? ठीक है. No teach P block. Thank you. Thank you, Lazy Dominic. You're liking this lecture with me. Thank you so much. I needed that feedback. Thank you. Okay, let's go. Reactivity towards hydrogen we're talking about. Okay, now first of all, the first thing that we are going to study is the reactivity order. So the fluorides will be the most reactive, then chlorides, then bromides, and then your iodides. Why? Because hydrogen is a chotu molecule. Hydrogen is a smaller molecule. Hence, it will form stronger bonds with another chotu molecule, which is smaller molecule, which is fluorine, right? So small molecules make stronger bonds with another small molecule. Hence, the reactivity order with hydrogen follows this order: that fluorine, then chlorine, then bromine, then iodine. Okay? Okay? Next is if I try to dissolve them in water. If I try to dissolve each of them in water, then bacha they will form hydro. If I dissolve them in water, H2O, then bacha they will form your hydrohalic acids. Remember this thing. They will form hydrohalic acid. Now what are you talking about? We're going to see the reactions one by one. Just right now, write these notes with me. Okay, what are these? We're going to discuss when the time comes. Okay, they are forming hydrohalic acid with water. Next is, let's talk about the boiling point, melting point, bond length of what? He, hydrides of halogens. Okay? For example, boiling point. What will happen to the boiling point? As I told you, as we move down the group, the size of the atom increases. If the size is increasing, the van der Waals is increasing, van der Waals forces increases, which means boiling point also increases. So the boiling point here follows HCl has the least, then HBr, then HI, and then your HF. Again, HF here has the highest boiling point due to H bonding. I've told you enough times. HF forms hydrogen bonding, which are stronger bonds and difficult to break. So HF has the highest boiling point. Otherwise, the order followed is this: HCl, HBr, then HI. HF is the only exception. The melting point, again, melting point depends only on the crystal structure. Hence, the melting point order is different. Melting point is HF will have the least melting point, then HCl, then HBr, and then your HI. So understand, boiling point and melting point are different. Boiling point depends upon majorly on the size, majorly on the bondings. Melting point depends upon the crystal structure. What crystal lattice is present, it depends on that. You're from Nepal, hi Drugology. The part 2 notes are already uploaded on the Telegram. If they are not, as people are saying, then after this session is over, along with these notes, I will send those notes. Pakka after this session, both the notes will reach on the Telegram channel. Okay, join the Telegram channel. Link is in the description box below. Next is we're talking about the bond length. Bond length, what will happen as the size will increase, as I'm going down the group, the size is increasing. The size is increasing, the bond length will also increase. Simple. So HF will have the smallest bond length, then your HBr, then your HCl, then your HBr, and then your HI. Isn't it? So this is the bond length order. Now we're going to talk about thermal stability. Stability means what? Which one will be the more stable molecule? Which one will be the most stable? Where always remember, because hydrogen is the smallest molecule, so it will form stable, more strong bonds with another small molecule, right? So here the small molecule is fluorine, then as we go down the size is increasing. If we are going down, the size is increasing, hence the bond length will also increase, and the bond length, always remember that bond length is inversely proportional to bond energy. If the bond length is increasing, the bond energy will, if the bond length is increasing, the bond energy will decrease. Hence, the thermal stability will also decrease. Hence, HF bacha is the most stable molecule, then HCl, then HBr, and then your HI. Correct? Next is your acidic strength. Again, I've told you many a times. Acidic strength means what? Anything which have the tendency to release H plus easily. Which will release the H plus out of these four molecules? Where the bond length is most, right? When the bond length is longer, it is easier to break. Hence, the acidity order will be ulta of thermal stability, opposite of thermal stability. Hence, HI will be the most acidic, then your HBr, then your HCl, and then your HF. Correct? So, however easy it is to break the bond, that will be the most acidic. Similarly, pKa. pKa, always remember, bacha, again another thing I'm writing here, pKa is again inversely proportional to acidity. Remember this thing. More will be the acidity, lesser will be the pKa value. Okay? So, highest acidic is HI. So, here HI will have the least pKa value, then your HBr, then your HCl, and then your HF will have the highest pKa value. Okay? pKa is inversely proportional to acidity. Similarly, reducing power. Reducing power will be the same as acidity. Why? Because reducing power again means how easily can it give away the hydrogen, right? So whenever it is easy to break the bond, break the H bond easily, it is easy to give away. For example, HI will have the longest bond, so it is easier to break the HI bond, right? So hence, HI will have the highest reducing power, then HBr, then HCl, and then your HF. So these are the reducing power trend. Next is the bond energy. It is the opposite of, I'm not writing it again, I'm just writing it. It is the inversely proportional to bond length. So whatever was the bond length order, the opposite will be the bond energy order. Dipole moment. Dipole moment is what? It is represented by mu and its formula is Q into D. Q is charge. Okay, always remember this. Charge into distance. Okay? That is called the dipole moment. Charge into distance is called the dipole moment. Remember this. Okay? Now in dipole moment, bacha, what is happening? As the electronegativity is more, the dipole moment will be more. Just remember this thing. Okay? So it means it is directly proportional to electronegativity. Okay? So the dipole moment order here that follows is HF has the highest dipole moment, then HCl, then HBr, and then your HI. So these are all the possible questions that can be asked from the reactivity towards hydrogen, these trends, these orders. What are the reason behind these things? I've also discussed you that. Okay, everything I've discussed in these long forms of lectures, correct? We will also do like short forms of lectures, but later on. But in those the reasoning, I will not make you understand again. So these lectures are very important to understand the reasoning behind things. Okay? Now reactivity towards oxygen we're talking about. We're talking about the reactivity towards oxygen. Remember this thing. We have talked about the reactivity with hydrogens. Now we're reacting the halogens with oxygen. So, bacha, all the oxides formed. Remember this thing. Majority of the oxides formed of these halogens are actually unstable. Unstable oxides are formed. Okay? For example, fluorine forms two types of oxides. One is the OF2 oxides and the other is the O2F2 oxide. Okay? Here, bacha, only OF2. Only OF2 is thermodynamically stable. Is thermally stable. Okay? What have I told you yet? Ki all the oxides that we form of the halogens are actually unstable. Generally, they are mostly unstable. I'm also writing it another word. Mostly they are unstable. For example, fluorine forms two kind of oxides, which are OF2 and O2F2 kind. Okay? So here among between these two, only OF2 is a thermally stable oxide. Okay? Now it is thermally stable at room temperature. Also remember this thing. Okay? Now बच्चा हम बार बार calling it oxides, which between oxygen and fluorine. As we know that fluorine बच्चा here is more electronegative element, isn't it? So these oxides that are formed over here will not be called oxides. Instead, what all they be called? Both of them, bacha, both of them will be called will actually be called oxygen fluorides instead. Oxygen fluorides. They are not called oxides. Instead, they are called oxygen fluorides because between oxygen and fluorine is more electronegative element. Hence, these are called fluorides and not oxides. ठीक है? ठीक है? Also remember one more thing, bacha. Both OF2 and O2F2, both of them are strong. What are they? They are strong fluorinating agents. Fluorinating agents. What does it mean? It means they easily give away the fluorine atom for reaction. Okay? For example, it's a very, very popular reaction called O2 between O2F2 and plutonium. So when I react O2F2 with plutonium, what happens? PuF6 is formed. Okay? Plutonium hexafluoride is formed. And bacha, this is very, very crucial. Why? Because plutonium is actually used in nuclear fuel, right? So plutonium is a end product of nuclear fuel, which is toxic, and hence to remove this from the nuclear fuel, you actually react it with O2F2 so that PuF6 can be removed. So in this form, plutonium is removed from your spent nuclear fuel. This is a very important reaction given in your NCERT. So please make use of this. Okay? So we now talked about with fluorine, what kind of fluorides with, like when I react oxygen with fluorine, what is formed? Oxygen fluoride is formed. Two kinds are formed and only one was stable and one was used in that reaction with plutonium. This thing is clear. Now we're going to talk the reactivity with oxygen with all the other three halogens. Okay? The other three halogens, if I try to react it with oxygen, what will happen? What will happen, bacha? Here, when I try to react with all of these with oxygen, actually various kind of oxides will be formed. What will be formed, bacha? Various kind of oxides will be formed here, and their oxidation states will range from +1 to +7. Remember this thing. Their oxidation states will range from +1 to +7. They will form too many kinds of oxides. With oxygen, they will form too many compounds and whose oxidation states will range from +1 to +7. Okay? And what is the stability? There and bacha, there according to the kinetic. Also remember one more thing. According to the kinetic plus thermodynamic Okay, according to the thermodynamic factors. These two factors we consider, and after considering these factors, what is the stability of the oxides? So, bacha, after considering the factors, the stability of oxides actually follows this order. Very, very important. This is a very random order because the order of stability of oxides is iodine is most stable, then is your chlorine, and then is your bromine. Remember this thing. So with oxygen, what is the stability order of oxide followed? Ki iodine forms the most stable oxides, then chlorine, and then bromine. Okay? With hydrides, what was the order? When I was reacting hydrogen with halogens, with the order was fluorine was the most reactive, then chlorine, then bromine, then iodine. Okay? But with oxygen, what is the order? Iodine is the most reactive or forms the most stable oxide, then your chlorine, and then your bromine. Okay? And with oxygen, if I try to react oxygen with chlorine, bromine, and iodine, I get compounds ranging in oxidation states from +1 to +7. Okay, everybody understood this? For example, let us talk one by one. For example, with chlorine. With chlorine, what kind of oxides can be formed? With chlorine, Cl2O can be formed. Okay? With chlorine, ClO2 can be formed. With chlorine, Cl2O6 is formed, Cl2O6. And with chlorine, Cl2O7 is formed. Everybody is understanding this? Everybody? Now let us write their oxidation state. Here chlorine is in what oxidation state? Can anybody tell me? Cl2O. Oxygen will get the -2 oxidation state, right? So here it is in, yes, physics and chemistry. What are you asking, bacha? So here chlorine is in what oxidation state? I think it is in +1 oxidation state. Isn't it? Because it is 2x minus 2 is equals to 0. So x is equals to +1. Here oxygen is in plus 2 to the 4 oxidation state, isn't it? Here it is in +4 oxidation state, 6 2s are 12 by 2 plus 6 oxidation state, 7 2s are 14 plus 7 oxidation state. Isn't it? So these are all the oxidation states shown here by chlorine. Okay? Now, bacha, what do you have to remember about these? About all these oxides of chlorine. What are these? These are various oxides of chlorine. Another thing is, as the oxidation state is increasing, what will happen? Their acidic character also increases. Remember this thing. Whenever the element is in the most highest oxidation form, the element whichever is in the highest oxidation form will have the most acidic oxide. Okay, so acidic character of oxide also increases. Number 1 point. Number 2 is all these oxides of chlorine, bacha, are highly reactive. Remember this thing. These are highly reactive oxides. These are very, very good oxidizing agents. Okay, and also, bacha, they tend to explode. Remember this thing. Because they're very explosive in nature. They're highly reactive. They're good oxidizing agents, and they are also very explosive in nature. Okay? And also remember, bacha, the Cl2O, which is given over here, the Cl2O is a very, very good bleaching agent. Good bleaching agent. Okay? Good bleaching agent. Who isn't these oxides strong? Yes, bacha, these oxides are very, very strong. These oxides are very, very strong. These are strong oxidizing agent. These are highly acidic. As the oxidation state increases, these are highly acidic. They tend to explode. These are explosive oxides. All the oxides of chlorine are explosive. They're highly reactive, oxidizing agent. And Cl2 is a good bleaching agent. Bleaching agent you can even use to bleach the paper that you make, or even your water. And in water, in pool water, bleaching agent is agent that can be your Cl2O. Okay? Next, we're going to read about the oxides of your, next oxides that we're going to read about is your bromine oxides. So bromine forms bacha Br2O kind of oxides, or your BrO2 kind of oxide, or your BrO3 kinds of oxide. Okay? Also remember that BrO3 out of these three is the least stable oxide. This is the least stable oxide. This is the least stable oxide. Why is it least stable? Due to middle row anomaly. Middle row anomaly. Anybody who asks you what is the reason for the stability of oxides and why is it the least stable, then what will you say, bacha? You will say due to the middle row anomaly. Actually, not even BrO3. Just remove this thing. All the bromine oxides, remember this thing, all the bromine oxides are least stable. Okay? Just do not just go for the BrO3. Actually, all the bromine oxides are least stable among fluorine, chlorine, bromine and iodine. Okay? And why all the oxides of bromine are least stable? Due to middle row anomaly. This is the reason given in NCERT. Okay? It means what, bacha? It means they only exist at high temperature. Okay? They only exist at high temperature, do not exist at low temperature, and also they are also powerful oxidizing agents. Another important thing. Okay? Now what we're talking about, these are bacha very, very powerful oxidizing agents. Okay? ठीक है, yes, clear, very good. So with chlorine they were explosive, with bromine they were least stable, but all of them, chlorine and bromine, both are good oxidizing agents, and their acidity increases. Again, in this case also, as the, what will happen as you're going here, as the oxidation state will increase, so the acidic nature of oxide will also increase. ठीक है. Next, we're going to talk about the oxides of iodine. What kind of oxides iodine form? Iodine forms I2O4 kind of oxide, or I2O5 kind of oxide, or even I2O7 kind of oxides. All these oxides are, bacha, insoluble solids. Insoluble solids. So all these facts you have to remember. This is inorganic chemistry. The questions will be asked from these random faltu facts, which will be like, ma'am, why have they given this thing? But the paper is going to be fact based, bacha. For the inorganic chemistry, it's going to be fact based. But it is easier to remember because in the starting only I mentioned that iodine is solid in nature. Hence, its oxides will also be insoluble solids. Okay? Why is it insoluble? Because iodine is a bigger molecule, cannot get soluble in water. Number one reason. Number second reason, all these oxides are covalent in nature. Obviously, they cannot soluble in water. Okay? And also, bacha, all these iodides are actually, they decompose on heating. All these oxides of iodine decompose on heating. Remember this thing. Decompose, they get decomposed on heating. Okay? Everybody understood this? The next point is, also, bacha, your I2O5. Remember this thing, I2O5 is a very, very important thing. Your I2O5 is used as a very, very good oxidizing agent, and it is used in estimation of carbon monoxide. Remember this thing. I2O5 is a very, very good oxidizing agent used in the estimation of carbon monoxide. All these things are very, very essential to understand. ठीक है? ठीक है? I am moving to the next thing. Reactivity with oxygen we have done. Now the last reactivity is a reactivity with metals. Again, understand, your halogens, which are group 17 elements, react with the entire periodic table, right? These halogens react with the entire periodic table, and I established in the very beginning that most of the periodic table are metals. 75% of the periodic table is just metals. So all these halogens react with the 75% of the periodic table and actually form what? And actually from your halides. Metal halides are formed. Okay? For example, what kind of metal halides? For example, magnesium, which is a metal, it is solid in nature. I try to react it with fluorine or Br2. If I try to react it with Br2, which is a liquid, what will happen? MgBr2 will be formed, isn't it? MgBr2, which is a kind of solid, will be formed. So what is happening? By reacting a halogen with a metal, I am forming a metal halide. Is this thing clear? A metal halide is formed. So, bacha, all these metal halides that are formed, what is their nature? Are they ionic in nature or are they covalent in nature? How will you know that? So, let me write it. So, bacha, any metal fluoride will be more ionic than your metal chlorides, then your metal bromides, then your metal, then your metal iodides. One second. Then your metal iodides. Okay? So, bacha, this is the ionic trend. Why? Because as the anion is smaller, this is again based on the very beautiful Fion's rule that you read in chemical bonding. You read it there. What happens when the size of the fluorine, when the size of the anion is small, the kind of bonding that happens is actually ionic bonding. So here, as the size of the anion keeps on increasing, the covalent nature will also increase as the size of the anion is decreasing. Hence, MF is the most ionic compound than your Mi. Okay? Okay? And also remember here all the metals are monovalent. Monovalent means what, bacha? All the atoms are in +1 oxidation state. Okay? Now, if I try to increase the oxidation state for the metals, right? So, halides so what will happen to the halides if I try to increase the oxidation state? So, halides in higher oxidation state. Will actually be, bacha, covalent in nature. Remember this thing. Halides in higher oxidation state will actually be covalent in nature. Why? Because as the oxidation state, what is happening? Okay, I am again respect to. For example, your metal is here. If your metal is in, for example, +7 oxidation, it means you have removed 7 electrons from the metal. So it means if I've removed 7 electrons, my metal, my atom has become too small, right? And smaller cations give rise to covalent molecules. Hence, halides in higher oxidation state are actually covalent in nature. Is this thing clear to everybody? Is this thing clear to everybody? ठीक है? ठीक है? For example, I will again write it here. Yes, I have a space here. For example, if I form tin tetrachloride, ठीक है? Or if I write PbCl4, or if I write SbCl4, or if I write UF6, uranium hexafluoride, ठीक है? And I'm again writing, for example, I write tin dichloride, or I write Pb dichloride, or I write Sb trichloride, or if I write U tetrafluoride. Now, which one will be more covalent and which one will be more ionic? So, can you see here, the oxidation state here is more, and here the oxidation state is just +4, right? Can I write +4 over here? Here the oxidation state is +2. So, can you see as the oxidation state is increasing? So, therefore, bacha, these compounds will be more covalent. Remember this thing. These compounds are more covalent and than these compounds. ठीक है? Than these compounds. ठीक है? So these compounds are not covalent. These compounds are covalent. So as the oxidation state is increasing, so is the covalency is also increasing. Oxidation state of metals. ठीक है? More oxidation state of metals, more covalent will be the compound. This is again the very beautiful Fion's rule in place. You don't have to mug up things because you've already studied Fion's rule. If not, I will make you study chemical bonding on this. ठीक है? Hello, happy Neet journey. Yes, bacha, this obviously this is based on the new Neet syllabus. That's what I've established on the beginning of the sessions, right? This is the part 3 that we're doing. We've almost completed all the P block. If you've not seen those videos, you can go back and see where I've discussed each and every PYQ ever asked in your exams, right? So we're doing PYQs plus the NCERT plus whatever can be asked all around it. Okay? According to the new NTA syllabus. Next compounds that we're going to talk about in the group 17 are the interhalogen compounds. Remember this thing. Thank you, Preetha. Interhalogens means what? When one halogen reacts with another halogen. For example, fluorine reacts with bromine, or bromine reacts with iodine, or iodine reacts with chlorine, right? So what is happening? One halogen is reacting with another halogen. Hence, they are called interhalogen compounds. And interhalogen compounds again can be of too many types. For example, the XX dash type. It means one, but always remember the X dash is the smaller halogen, ठीक है? Halogen, and your X is the bigger halogen, obviously is the bigger halogen, ठीक है? So for example, CLF, BRF, BRCL, ICL, IBR, these are all XS dash type. Now XS3 dash type. So can you see that, for example, CLF3, BRF3, IF3, ICL3. Okay? So what is happening? The smaller, the X dash is the smaller halogen. The smaller halogens are actually can be many in number. The larger halogen will be in the middle. Similarly, it can be XX5 dash type or XX7 dash type. Okay? Also remember one more thing. What is happening as the ratio of the radius of X and X dash. X has some radius and the X dash has some radius. Okay? So as the ratio of the radius of X and X dash is increasing, can you see here iodine is a much bigger molecule and fluorine is the smallest halogen molecule, right? So when the ratio between X and X dash is increasing, it is the biggest ratio, hence it will form the maximum number of, it can attach the maximum number of smaller halogens to it. Okay? Remember this thing. For example, IF7 is only possible. ICL7 or even IBR7 is not possible. Why? Because there is not enough, the radius ratio is not that much. Here the difference in radius is so much, right? Iodine is a very big molecule, fluorine is a very small molecule. Hence, due to the size difference, they can make up to 7 heptafluorides over here. But this is not possible when they have comparable sizes. Just remember this thing. Okay? These are interhalogens compound. Now, how they are prepared? Just look at these compounds. it is simple again. When I react chlorine with fluorine, what will I get? ClF. When I react chlorine with 3 fluorine, I will get ClF3. When I react iodine with chlorine, I will get ICl. When I react iodine with 3 chlorine, I will get ICl3. So these are preparatory methods. These are very easy preparatory methods. Okay. Next is, what is their shape, ma'am? Very important questions come out from their shape every year. So what is happening? I took the XX dash. So the only structure to make a XS dash kind of compound is a linear structure. So these are actually linear in structure. These structures are not given over here though. Now XX3 dash. XX3 dash means what? What is this structure? This structure is bent T-shaped. Ma'am, what do you mean by that? So let's not look at here. Let's look at these structures. See, this is XX3 dash. This is XX5 dash. This is XX7 dash. Okay, now look at these structures. XX3 dash, this is not a T shape. This is actually a bent T shape. What do I mean by that? Now look at this structure again. Can you see, I already established in the starting of the chapter key the lone pair of electrons, right? The lone pair of electrons which are present on the bromine atom. Let me select a pen color. One second, yes. So, bacha, what is happening over here? The lone pair of electrons are actually taking up the equatorial position. Can everybody see? Equatorial position is actually taken up by the lone pair of electrons. And what is that doing? That is actually causing repulsion to these fluorine atoms which are present in the axial position, right? So due to this repulsion by the lone pair of electrons, it actually gets a T shape, but that is a bent. That structure is actually bent due to repulsion. Hence, it is called a bent T-shaped molecule. Okay? So, XX-3 ties will be a bent T-shaped molecule. For example, this. Next is the BRF5. It will be a square pyramidal structure. Square pyramidal structure looks like this. Bromine is in the middle and 5 fluorines are attached. So, 4 fluorines will be in the square planar position and 1 will be on top of it, and the lone pair will be below. And this structure is called the square pyramidal structure. And IF7, bacha, IF7 will have a pentagonal bipyramidal structure just like this. Okay? So this is how you have to remember the structures of these. Very, very important. The structures are asked every year. Now, physical state and color is never asked. But to be, if you have time, to be on the safer side, because inorganic practical chemistry is in your course. So there is a high chances of you getting asked what is the color of that compound, what is the physical state of that compound. This is a high probability. Okay? But only and only if you have time, if you've completed all the course, only and only do this. Otherwise, type, formula and structure are 3 most important things that you have to do. Okay? We have discussed this. Now let's discuss some properties of the interhalogen compounds. Number first property that I'm going to tell you about the interhalogens. What do you think are the properties? Properties are, there are so many halogens attached together. If there are so many atoms attached together, then mostly, bacha, they will be covalent in nature, right? They're all covalent in nature. They are mostly diamagnetic in nature. These are 2 of the most important properties of these interhalogens. Okay? The next thing is, these are volatile solids or liquids. Next thing that you should know are, these are volatile, means they are easy to evaporate. They have low boiling points. They are volatile solids or liquids. Can be solid, can be liquid, but there is again an exception, except ClF, which is a gas. Why is it an exception? Because fluorine is a smaller molecule, chlorine is also comparably smaller, and this is a gas. All others are solids or liquids. Okay? Now, what is, ma'am, if I am mixing 2 halogens together, what happens to their physical property? For example, if I am mixing Cl and F together, what will happen to the physical property? Will it behave more like fluorine or will it behave more like chlorine? What will be the physical property? So, bacha, their physical property will be somewhere in middle of these 2, right? Because we have mixed both of these together, so the physical property will be in the middle of these 2 things. Okay? The next thing that we're going to talk about is melting point, boiling point. Have I okay, here only I'm going to write it. So this is clear. Next thing that we're going to write is what happened. Okay, ma'am, I understood about the physical property, that it will be somewhere between the 2. What will happen to the melting point and the boiling point? So, bacha, melting point and boiling point actually is higher than expected. The boiling point, melting point increases when you mix these 2 things, and they're higher than expected. ठीक है. And what are the other things ma'am I should know? It is that कि बच्चा interhalogens, we're talking about interhalogens, right, which are made by combining two kinds of halogens. So बच्चा interhalogen compounds actually are more reactive, remember this thing, they are more reactive than what? Interhalogen compounds are bacha what? They are more reactive than halogens. Remember this thing. They are more reactive than halogens. Simple halogen, simple chlorine, simple fluorine, simple bromine, simple iodine. They are more reactive than simple halogens. But there is again an exception. Except your fluorine. Except fluorine. Why? Because I just told you कि fluorine atom, this fluorine bond is easier to break, right? The fluorine bond has a low enthalpy of dissociation because there is so much of repulsion between two atoms, correct? So except fluorine bond is bacha more reactive. Remember this thing, more reactive. Even though if I compare with other halogen atoms, interhalogens are more reactive, but exception is fluorine. Why? Because bacha the fluorine bond is so much stretched because there are so much electronic repulsion between the FF bond, it is easier to break that. Hence FF, fluorine, is more reactive than a interhalogen compound. So this is the only exception that exists. ठीक है? ठीक है? What I mean to say is that the interhalogen bond is actually a weaker bond, correct? But the fluorine bond is actually weaker again. So fluorine is the only exception, because XX dash bond is easier to break. This is a weaker bond, easier to break, hence it is more reactive. Than halogen. Everybody is understanding this part? The interhalogen compounds are more reactive than halogens except fluorine. This is the point that I'm trying to make. Okay? The next is, if I try to react the interhalogens with water, what will happen? Okay, with water, what will happen? So too many kinds of things will happen. For example, these lines are very, very important. Please understand these lines once again. Yes, correct. So what will happen, bacha? All these will undergo hydrolysis. These interhalogen compounds, I'm trying to react it with water. So with water, when I'm trying to react, it will actually form the XX dash. The XX dash will actually form a smaller halogen and a hypohalite. Okay? Or it will form a halite when XX3 dash. Or if I try to react XX3 dash with water, I will actually get a halite. If I try to react XX5 with water, I will get a halate. And if I try to react XX7 with water, I will get a perhalate. Ma'am, what are these things? We are going to study in oxoacid. Right now, just this screenshot is important and I'm attaching in PDF. Once you go through the oxoacid thing, you will understand what is halite, what is halate, what is perhalate. Just right now understand this, that when XX5 dash with water reacts with what happened, and when XX7 dash reacts with water, then what happened. Okay? These things are important. These are some of the uses that you can go through. Again, a NCERT screenshot that I've attached over here. Okay? The next is, I'm back to the oxoacids of halogen. Very, very important point. Oxoacids of halogen means what? With the halogens, I'm reacting oxygen plus hydrogen. So it is a compound of oxygen and hydrogen, hence can be asked in your exam. Please do not skip oxoacids of halogen. So with fluorine, bacha, only one kind of oxoacid is formed, which is called HOF. Its name is hypofluorous acid. Fluorine only form one kind of acid, which is also called hypohalous acid. And chlorine also form hypohalous acid, bromine and iodine. All these form hypohalous acid. Next is the halic acid. Okay, halic 3 acid, also called the halous acid. Okay, fluorine doesn't form any of these things. So halous acid is only and only formed by chlorine compound, which is called chlorous acid. Next is your halic acid. Halic acid is formed by again all the three, which is chloric acid, bromic acid and iodic acid. And with your perhalic acid, in which you have 4 oxygen. See, what you are doing in hypohalous, there was just 1 oxygen. Remember this is. It had 1 oxygen. With halous acid, you had 2 oxygens. And with halic acid, you had 3 oxygens. And with perhalic acid, you have 4 oxygen. That is it. You are increasing 1 oxygen. Okay? So, for example, in halic acid, which is also called perhalic acid, your HOClO3, perchloric acid, perbromic acid, periodic acid is formed. Okay, so these are all the structures of halic acid. And just remember, fluorine only form one kind of halic acid, which is hypohalous acid. The rest of the things form all kinds of acid, and halous acid is just formed by chlorine. Okay? Now, what are their structures? So, bacha, HClO4 has a structure like this. HClO3 has a structure like this. This is the HClO2 structure, and this is the HOCl structure. HOCl is very easy. This is chlorine. With chlorine, you have attached a OH molecule. HOCl2, again with the chlorine, there will be a OH molecule present. Okay, so I have used one H, one oxygen. One oxygen is left, so I will draw structure like this. Okay, but it will be a bent structure due to the presence of these lone pair of electrons. So this is the structure of HClO2. Okay, everybody is understanding this point. So please look at these structures, because structures are very much asked in your exams. Okay, very much. More reactive than halogens. Are they acidic? Rita, what is your question? Satvik, what is the question? Beta, what are acidic? What are you asking about? These halous acid. Yes, these are acids. These are obviously the acidic. These halous acid are very acidic, bacha. Can you see that as the oxidation state is increasing? Can you see here the oxidation state of chlorine is +7. Here the oxidation of chlorine is +5. Here the oxidation of chlorine is +3. Here the oxidation of chlorine is +1. Can you see? So as the oxidation state is increasing, I just told you, as the oxidation state increases, hence the acidic character also increases. Hence these are more acidic, very acidic compounds. Okay? Beta, what is your question? You can ask me, then I will reply to you. Now we are talking about group 18. Last group we are here. Group 18 is also called the noble gases. Noble gases, right? And it is also called the zero group, right? These are also called noble gases. Why? Because, bacha, their electronic configuration is NS2NP6. Totally complete, fully complete electronic configuration. Hence, it was believed that these, because their electronic configuration is complete, hence they are unreactive molecules, hence they will form no compounds. But later on, it was discovered that they do actually form compounds, right? And what are the group 18 elements? These are helium, neon, argon, krypton, xenon, and radon. Remember this thing. Okay? Helium, neon, argon, krypton, xenon, and radon. Now, their occurrences are very important. You should go through this screenshot given in NCERT. I'm not going to dictate it out. Okay? I've already stretched it out. Go through this occurrences PDF. I'm already attached it here. Now, I told you that these are also called the zero group family, right? Because it is actually based on the Mendeleev's periodic table, why it is called the zero group. You don't need to get into that. Just remember, they're also called zero group. Okay, you actually read it in when you are reading the periodic properties chapter. Okay, and these are the configuration. Helium here has the 1s2 configuration. So is helium, ma'am, p block element? Answer this in the comment section below. Okay, is helium a p block element? Because look at the configuration of helium. It is just 1s2, है ना? 1s2 configuration. Is it a p block element? And radon is radioactive. These are the electronic configurations that happen. Now the atomic radii. What are the trends that are followed? So, bacha, as we go down the group, obviously the atomic radii will increase because the shells are increasing. What happens to the ionization energy? As the size is increasing, the ionization energy decreases. Electron gain enthalpy. These are the only atoms, only elements who have large positive values of electron gain enthalpy. Which means what? If this is the atom and I have to give electron to it, I am a noble gas. I already have a complete octet. I do not need any more electrons. I'm already stable. Why do I need more electrons? But if you're still trying to give me more electrons, then you have to give me energy, right? So when you are giving energy, then the positive value will come. Okay? Positive means you are giving the energy, right? So therefore, the only elements with the large positive values of electron gain enthalpy are your group 18 elements. Correct? Next is some properties of group 18, that these are all monoatomic colorless, right? Helium is found as helium only. Helium is not found as helium 4 or helium 2, right? It is not found as these structures. It is only found as helium because they are monoatomic. These are colorless gases. Okay? If they are gases, which means what? That they have a very low boiling point, right? Only then, if something is a gas, it means it has a very low boiling point. They are also sparingly soluble in water. They have a low melting and boiling point. Why? Because of weak dispersion forces between atoms, which means what? That they have weak dispersion forces because they have no unpaired electrons in them. And also what happens to the boiling point? As I'm going down the group, the size is increasing. So when the size is increasing, the boiling point also increases down the group with the increase in strength of dispersion forces. And hence helium has the lowest boiling point. Remember this thing. Which element has the lowest boiling point? It is actually helium. So all the group 18 elements are monoatomic gases. They are gases, hence they have a low boiling point. But as we go down the group, the size will increase, hence the boiling point also increases. Okay, due to the dispersion forces between them. Okay, now these are some of the other things that you should know about. Let me select another pen color. Where is my mouse? Yes, here. The other thing is, bacha, in your chemical properties, what you have to see. For example, these are least reactive or chemically inert elements. Okay? Why? Because their electronic configuration completely filled. I just told you they have a NS2, NP6 kind of electronic configuration, fully filled, noble gas configuration. Hence, they do not react much. They have a very high ionization enthalpy. This is the second reason that they are least reactive. And they also have large positive electron gain enthalpy. Ionization energy means what? The ability to lose electrons, right? Because they have high ionization energy, they cannot lose electrons easily, and they have positive electron, large positive electron gain enthalpies, and they also cannot gain electrons. So they're not even losing electrons easily, not gaining electrons easily. Hence, they are what, bacha? Highly unreactive compounds. They're chemically inert. Previously, it was thought that they do not react at all. But later on, many compounds of noble gases were discovered, and it was found that they do react. Okay, they do react actually. And what are the common questions from these, bacha? I have included in this slide. The common question from the group 18 are just the structure based question. Like, what are the compounds formed by the xenons, right? These are the most important questions that are asked. Nothing else is asked on group 18. Okay? From group 18, what is the structure of XCF2? It will be asked. Again, remember that, see, look at the structure of XCF2. It is a linear structure. Can you see it is a linear structure? Because all the lone pair of electrons are at the equatorial position. Remember this thing. These lone pair of electrons are at the equatorial position, and your at the axial position, the fluorine atoms are attached. So this is the Xc molecule, and this is the fluorine molecule, and this is again the fluorine molecule. Similarly, xenon tetrafluoride. What happens? All the fluorines are at the square planar position, and on the top and on the bottom, what is happening? On the top and the bottom, your electron pairs are present. Okay? And the structure of xenon hexafluoride is actually this kind of structure. It is pentagonal bipyramidal, but it is actually distorted. So what is its name? Its name is actually distorted. Can you see there's a lone pair of electron also here? So XeF6 has a distorted octahedral structure, distorted pentagonal bipyramidal structure, whatever you deem. This is a distorted structure. Okay, now xenon oxygen compounds. These were the xenon fluoride compounds. Xenon oxygen. For example, XeO3 asked so many times what is the structure of XeO3. You should know how to draw the structure. XeOF4 has this kind of structure where oxygen is at the axial position. All the fluorines are occupying the square planar position, and one electron pair is at the bottom. And XeO2F2 has a structure just like this. Okay? Again, the lone pair is at the equatorial position. Always remember, the lone pair will come at the equatorial position. Okay? XeO2F2 has this kind of structure. Now, these are some of the reactions given in your NCERT, which I think you should know. For example, when I'm trying to make xenon fluorine compounds, what are the reactions? With xenon and 1 fluorine, I get ZeF2. With xenon and 2 fluorines, I get ZeF4. With xenon and 3 fluorines, I actually get ZeF6, and the ratio is 1:20. Okay, these are important reactions, can be asked. Next is xenon fluorine compounds. Once again, when I react xenon difluoride with phosphorus pentafluoride, I get a ionic structure just like this. So these are xenon trifluoride with so you get all these structures. So these are xenon fluorine compounds, some of the reactions. Again, there's nothing to explain. You just need to know these 2-3 reactions are there. There's nothing. It will just form an ionic structure just like this. You got to know that. ठीक है. Again, when I'm doing the hydrolysis of ZeF4 and ZeF6 with water, it gives ZeO3. So these are again screenshots of NCERT is given. I have nothing to explain. These are just reactions. What happens if 3 moles of hydrogen is, H2O is added with xenon hexafluoride with 2 moles of water? What happens? So these, I have nothing to explain, right? So different kinds of compounds are formed, and the structures of those compounds we've already discussed. What is the structure of ZeO3? What is the structure of ZeO4? What is the structure of ZeO2F2? We've already discussed all these structures, right? These are the important questions. The reactions can be asked. Okay, so to be on the safer side, I've included all these things. Okay, now we are back to solving some of the PYQs. Neet 2023 PYQ. Who's going to solve this question with me? Good afternoon, Kiamat. Good afternoon. Yes, bacha. Bacha, you can for once you can skip the preparatory methods, but please do not skip the structures. Structures will definitely come in your exam. Matlab, I'm not joking. Definitely, pakka se pakka come from a P block. ठीक है? Who can answer this question for me? So, bacha, I have attached the P block. I can describe the acidity trend in group free hydrides based on the electronic structure events. Hell game is asking me one question. But group 15 we have already discussed. Some child is asking me the acidity trend. So but group 15 we've already discussed. Na? I've already discussed in the last lecture only. You can go and see. So I will once again tell you for the group 15 acidity trend of the acidity trend follows. Bacha, NH3 is the least acidic. Then your pH3. Then your as nitrogen phosphorus arsenic antimony and your bismuth. Okay, this is the acidity order followed. Why is that the case? Again, I'm telling you. Bismuth is a very large atom. Remember this. Bismuth is at the bottom of the periodic table, right? Nitrogen, phosphorus, arsenic, antimony, bismuth. That's how you write the periodic table. Now here bismuth is at the end. It has the largest size, right? So the largest size will form the longest bond with hydrogen. And we know that it is easier to break long bonds, right? So whatever bond is easier to break will be most acidic, because acidity is what which easily gives away the H plus ion is actually the acidic compound, isn't it? So here this is the acidity order followed. ठीक है? ठीक है? I think I explained it to you. This is the reason behind the acidity. Now these are some PYQs attached which you will get in the PDF attached. I will attach the I will send the PDF to the Telegram channel, right, bacha? So these are, look at these PYQs. This is one PYQ, second PYQ, third PYQ, fifth PYQ. See, again, structure-based PYQ from your group 18. From your group 18, mostly those are. And which of the following statement is not true for halogens? Okay, so I've included so many PYQs over here, bacha. Okay? Okay? So many PYQs. So you can go and just pause the video somewhere if you want to solve by looking at the video. Okay? Or you will get in the Telegram channel. The link is in the description below. I will upload the notes. All these PYQs will be there. Okay? So I will meet you again in the next class. Okay? Beta, take na. What are your doubts? I will take your doubts. I will take your doubts. So if you want to do more PYQs right now, we can do the PYQs. Let's start with the NEET 2023 PYQ. Are you interested in doing the PYQs? Yes, Ansh, you can ask any doubts. I will take your doubts. Please ask me the doubts. ठीक है? NEET 2023 given below are two statements. One is labeled assertion and the other is labeled reason. Assertion is helium is used to dilute oxygen in diving apparatus. This is a very true statement. Helium has high solubility in oxygen. This is a false statement. Okay? This is a NEET 2023 question. Okay? So I've given you the answer over here. These are the uses of helium, which are no longer in your course, but because this is a PYQ, so you must know. All the PYQs you must do, right? Now, NEET 2021, statement 1. Acid strength of increases in the order given below. Is this the correct acid strength? Is this a true statement or is this a false statement? Who can answer this? Statement 2. As the size of the element increases down the group, the bond strength of HFHCl, HBr, HI decreases, so the acidic strength increases. Is this a true or a false statement? Who can answer this? I'm looking at chat box once again. Let me know the answer to this question. This is a NEET 2021 question. Ansh, what are your doubts? Ansh just wrote, ma'am, doubts. So what are your doubts? Tell me the doubt now. True. First answer I got by Kavya. True. Very good. The first statement is true and even the second statement is true. What is happening? As the size of the iodine is increasing, hence the bond length with hydrogen will increase. It is easier to break longer bond lengths. Hence both the assertion, statement 1 and statement 2 is true. And statement 2 is also the correct explanation of statement 1. Okay? Now again need 2021 question. Noble gases are named because of their inertness towards reactivity. Identify an incorrect statement about them. What is the incorrect statement about them? Who can answer this? Now, option number A. Noble gases have large positive values of electron gain enthalpy. Is this a true statement? Yes, this is a true statement. They have large positive electron gain enthalpy values. Number B. Noble gases are sparingly soluble in water. This is also true statement. Abhi, I discussed all these things, right? Noble gases have very high melting and false. They have very low melting and boiling point. You can see these are noble gases. Gases are what? Which have low boiling points. That's a gas, right? And their weak dispersion force is true. So C option is the incorrect statement. Correct, Kavya. Correct, Kiamat Malik. Very, very good. Very, very good. Okay, next. Next is match the xenon compounds in column with its structure. Who can tell me the structure of these compounds? Xenon F4 has what kind of structure? Xenon F6, xenon oxygen fluoride and xenon trioxide. Who can tell me the structure of these compounds? For example, tell me, ma'am, A will have this structure, B will have this structure, C will have this structure and D will have this structure. Who can tell me the structure of these compounds? Xenon F4, what kind of structure does it have? I think it has a what kind of structure? Square planar, isn't it? I will give you 30 seconds to answer. Answer this question for me. Answer this question for me. A4. Somebody is saying A4. That is a wrong, bacha. A is not 4. A is not 4. Xenon F4 has what kind of structure? This is xenon. 4 fluorine atoms are here, right? Fluorine, fluorine, fluorine. And this xenon has 2 lone pair of electrons over here. So what structure is its form? This is a square planar structure, isn't it? 2 lone pairs are above and below the plane and the rest of the fluorines are in the square planar position. Xenon F4 is square pyramidal, ma'am. Xenon O4 बोल रहे हो बेटा, there is no question about xenon O4. What kind of A4? 2, A2, B4. Okay, Kavya has answered, ma'am, A2. Okay, this is correct, A2. And B, she is answering, ma'am, XCF6 has what structure? B4, square pyramidal structure. XCF6. Beta, no, bacha. XCF6 have what kind of structure? This is xenon, right? F6 means I have to attach 6 fluorine atoms. So 4 fluorine atoms will be in the square planar position, right? And the other 2 fluorine atoms will be in the upper wale position, upper and niche, top and below, right? Now what will happen to the another lone pair? Xenon here doesn't, xenon has 1, 2, 3, 4, 5, 6 electrons only. Where will the other lone pair of electrons go? It will come over here, right? Right? So this shape is actually a distorted octahedral shape. So B is actually 3. Correct? Now again, who can answer for the rest of the 2? C and D, what are the answers? A2, B is 3rd, not 4. Kayamat, A is 2 and B is 3rd. Distorted octahedral. ठीक है? Distorted octahedral. Next is for xenon XCOF4. What will be the structure? C4, somebody is saying square pyramidal. Ansh has answered to me square pyramidal. Okay, let's draw. This is xenon and fluorine atoms will be at the square planar position. Correct, correct, correct. Oxygen. So oxygen will form 2 bonds like this. What structure is this? Square pyramidal. Very, very good. XCOF4 will have a square pyramidal structure. So xenon oxide will have a pyramidal structure. This is the correct answer. ठीक है? ठीक है, everybody understood? This is the right answer. D1. Yes, Kavya. ठीक है, everybody understood? Now next question. Need 2017 again a structure based question from your interhalogen compounds we just discussed, right? Match the interhalogen compounds of column 1 with the geometry in column 2 and assign the correct code. Who can answer this question for me? Interhalogen, what will be the shape of XX dash compound? XX dash, answer me like this. A ma'am this, B ma'am this, C ma'am this and D ma'am this. Okay, I'm looking at the chat box again, giving you 30 seconds. This is a very easy question. Very easy question. Kavya has answered D1. D is 1. T-shaped. How can D be 1, bacha? B1. Okay, Ansh has answered B is 3. B is not 3. Wrong, you are giving me answers. Wrong, you are giving me. What did you learn in this class? What did you learn? Huh? XX3 dash means what? What kind of structure it will have? For example, Cl is here and I'm trying to attach 3 fluorine atoms. So the fluorine atoms will be here. Fluorine, 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 right? And 2 lone pair of electrons will be at the equatorial position. Can you see that this is a T shape, but a bent T shape, but the most appropriate option seems to be B to be 1. Okay? So B is 1, bacha. Similarly, your XX5 dash. Yes, Kavya is right with B1. And that's okay, Ansh, but you should understand the concept. Kavya is saying C4. C is 4, square pyramidal. Okay, let's draw the structure XX5 dash. For example, I'm drawing CLF5. F5 means 1, 2, 3, 4. F will be here and a lone pair of electrons will be here. This will be again square pyramidal. Correct. This is a square pyramidal structure. Correct. XX7 dash is pentagonal bipyramidal, isn't it? D is 2. Kavya is again right. D is 2. Again, you're right. So, therefore, XX dash is actually a linear structure. XX dash is a linear structure. Correct? So, these are all the structures given over here. Everybody understood? ठीक है? Shall I move on to the next part? Neet 2016 question. Neet 2016 question once again. Match the compounds given in column 1 with the hybridization and shape in column 2. Mark the correct option. Who can answer this for me? XCF6, what does the shape? Again, see, these shape wale questions are repeated every year. So, you should know the shape. Abhi we discuss what is the shape of XCF6, what is XCO3, what is XCF4. We've just done this question. This is again repeated. Can you see? The same question, NEET 2016 question was repeated in NEET 2019. Same question was repeated 3 years later, right? So this is, I'm giving you homework question. Let me know in the comment section below. We'll go on to the next group 17th question. Among the following, correct order of acidity. Yes, very good, very important question. Who can answer this for me? Hello, Junaid. Correct order of acidity. Correct order of acidity. Yes, Ansh, I'll write it in the comment section, not right now. We have moved on to the next question. Answer this NEET 2016 question. Among the following, the correct order of acidity. Fourth answer, somebody has said Savani, Pendem and Kavya both have given me the correct answer. Very good. The answer is this. Because I told you, as the oxidation state of atom increases, acidity also increases. So here the chlorine is in 4 2s are 8. Okay, 8 plus 7. So here it is in plus 7 oxidation state. 3 2s are 6 plus 5 oxidation. 2 2s are 4. 3 oxidation state. And this is plus 1. Okay, so as oxidation state is increasing, the acidity also increases, and HClO4 is the most acidic, HClO3, HClO2, HCl. Okay, by looking at the oxidation state of the central atom, right? Now APMT 2015 question. The variation of the boiling points of the hydrogen halides. So you're asking about the boiling points order is given to you. Is this the correct order? What explains the higher boiling point of hydrogen fluoride? This is a true order, right? HF has the highest boiling point and then it is HI, HBr and HCl. This is the correct order given. But they are asking you why is HF has a higher boiling point. Very easy explanation. Who can answer this? Who can answer this question? Okay, Sravani Pendem has already answered D. The electronegative fluorine is much higher than the other elements in the group. This is wrong, bacha. This is not the answer. This is not the answer. Who can answer this? Wrong answer given by Sravani. Bacha nahi. Ek aur baar. Read it once again. You will get the answer. Kavya has again answered 4. No, bacha. 4th is not the answer. 4 is not the answer, please. What explains the higher? Why does hydrogen fluoride have a higher boiling point? Ansha has answered 2. Ansha has answered A. Kavya has answered 2. A. There is a strong. Very good. The answer is A. Why? Because in HF, there is a presence of hydrogen bonding. Only and only with fluorine. See, hydrogen bond is formed by just 3 elements, which is oxygen, fluorine and nitrogen. Only these 3 elements can form hydrogen bond. No other element can form hydrogen bond. Hence, because in HF, H bonding is possible. Hence, they have a very high boiling point. So, answer A is correct. All others are wrong. ठीक है? Kavya and Sravani, you were wrong. Please look at the correct answer. Now, Neet 2013 question. Identify the incorrect statement regarding the molecule XCOF4. Very, very interesting. I love this question. Who can answer this? Right now, we drew every structure, right? So, identify the incorrect statement regarding XCO4 molecule. This is again a group 18 question. Who can answer this? Who can answer this? Hello, Junaid. Ansh, I'm waiting for your answer. Kavya, I'm waiting for your answer. Sravani, I'm waiting for your answer. XCO4 molecule is square planar. Incorrect. Okay. They have 4 p pi d pi. Okay. Okay, one more. Sravani has also answered A. Ansh has also answered 1. ठीक है. Everybody has answered 1. ठीक है. So let's draw the structure of XCOF4. XCOF4 must have a structure like this. Isn't it? So how many? 1, 2, 3, 4, 5, 6, 7, 8. This is the structure. This is a tetrahedral molecule. XCO4 is actually a tetrahedral molecule. So this is the incorrect statement. Correct. So the incorrect statement is only 1. We don't have to look forward. It has 4 p pi d pi bonds. Yes. Now what is p pi? See, now understand this concept. Oxygen only contains p orbitals and xenon has d orbitals as well. So can you see there are double bonds forming here? So these double bonds are called pi bonds, right? We have understood this concept long back. Double bonds, multiple bonds are called pi bonds. Now these multiple bondings are formed between the p and the d orbital of oxygen and xenon. Hence, these multiple bonds are called p pi between the oxygen and d pi between the fluorine. And there are 4 p pi d pi bonds. Correct. This is a true statement. True statement. And there are 4 sp3p sigma bonds. Yes, true statement. It is tetrahedral, true statement. Hence, the only incorrect statement is A. Very, very good answer. Very, very good. Next, again, Neet 2013, 10 years back, PYQ. Which is the strongest acid of the following? Who can answer this question for me? Which is the strongest acid? Very, very important question. If you answer this question correctly, it means your concept are crystal clear. You have crystal clear concepts if you answer this question. I'm looking for your answer once again. Neet 2013 question. Neet 2013 question. Kavya has answered A. Very good, Kavya. Very, very good. Very, very good, Kavya. Correct. We have to again look at the oxidation state. Here chlorine is in +7 oxidation state. Here sulfur is in 3 2s are 6 and -2 +4 oxidation state. Correct. Here the sulfur is in 4 2s are 8. -2 is 6 +6 oxidation state. Here it is in 3 2 is 6 +5 oxidation state. Correct. So can you see that the maximum oxidation state is shown by this chlorine? Hence this is the most acidic compound. So you have to look at the oxidation states. Here HClO4 chlorine is in the highest oxidation state. Hence it is the most acidic compound. Very, very good, Kavya. Very, very good, Ansh. Very, very good, Sravani Pendem. Very good. Very. So we have completed 10 years of PYQs with every theory part of the entire P block in 3 parts, right? So I've completed and covered everything that is even possible to get asked in your exams. I hope you like this session. And to get the notes, you can download it from the Telegram channel linked below. And thank you for joining the session. If you have any feedback, positive, negative, And ma'am, why are you doing that? Why are you not doing that? Ma'am, we want to learn this. We don't like to learn like this. Whatever feedback, like positive, negative, whatever, or anything you want to say, let me know in the comment section below, and I will see you again in the next video. Bye bye. Thank you for joining. The highest, okay, I've received one more question once again. The highest value of oxidation number changes from this to this in group 13 to group 18 respectively. Ma'am, please answer. The highest value of oxidation number from this to this in group 13 to group 18. But I guess for that it should be highest should be -3, because -3 is shown by -3 is shown by nitrogen. Okay, below that it doesn't go. So the change in oxidation state from group 13 to group 18 is from -3 it can go to actually +7. I don't think anything shows +8 oxidation state anywhere. +8 is shown by D block elements because your question considers the P block elements. So this should be the answer. -3 to +7 should be the answer. Ma'am, what to skip from this chapter? Beta, what to skip from this chapter? You have to skip all the compounds. Okay? After all the compounds of groups. What do you mean by that? These are the skipping part. You don't have to do this. See, after, for example, in group 13, what happens? Once your trends are over, atomic trends, radius, ionization energy, then comes the reactivity with oxygen, fluorine, and hydrogen. All these things are very important. Okay? Then afterwards, you will come across compounds of boron. है ना? There is a topic of compounds of boron. ठीक है, compounds of aluminium. All these things you don't have to do. You don't have to do the preparatory methods. Do not have to do the compounds. But what you have to do? Any structure that is made there. For example, in your 13th group, what happens? There are all the structures of the phosphoric acid, है ना? Of the haloacids of phosphorus. Then in 16th group, there are structures of the haloacids, oxoacids of sulfur. Then in your 17th group, oxoacids of halogens are present. Correct? So all these things you have to do. The structures, whatever are present, you have to do. Otherwise, you do not have to do any compounds of boron or aluminium, any compounds of nitrogen or phosphorus. You do not have to do. Do not have to do the preparatory methods. Any compounds of carbon, you do not have to do. Hana? So you do whatever I've taught you in these session series. Now, if you want to go through the syllabus one by one, then please go through the topics. I have sent you the PDF, right? In the PDF, there will be topics present. So just go through those topics and do not follow any other topics. All the compounds, just leave it. All the preparatory methods, just leave it. ठीक है? I hope I answered your question, Hell Gaming. Ma'am, in the options they have given specific for group 13, 14, 15. Acha, like that. I thought the entire periodic table. ठीक है? So, बच्चा, for I have taught you, bachcha, Hell Gaming is questioning me various questions. The question by Hell Gaming is, ki ma'am, what will be the highest value of oxidation number changes from dash to dash in group 13 to group 18? So, bachcha, group 13 means what? What all oxidation states does it show? See, I have taught you when I was teaching you group 13 that its oxidation state is NS2NP1, right? So what are the oxidation states can it show? It can show +1 oxidation state, and also it can show the +3 oxidation state, correct? So the minimum and the maximum is +1, +3. Similarly, for group 14, what will happen? It is NS2NP2, the electronic configuration. Therefore, what can be the oxidation state? So it can be +2 oxidation state. Also, it can be the +4 oxidation state, correct? So these is how you will approach these questions. Okay? So again, for group 15, what happens? Group 15 actually shows from -3 to actually +5 oxidation states. So I've actually discussed all these things, bacha. If you want to know more, please go through those lectures. Please go through. Only 3 parts are there. You can go through those lectures. Okay? Okay, everybody. Similarly, for group 16, 17 and 18, group 6. Okay, Hell Gaming. Okay, this is how you have to approach these questions. Thank you so much for attending the class. Do not forget to join the Telegram channel where you will get the notes today itself. Thank you so much. Bye-bye. This is your Nandini ma'am. And so please do not forget to leave comments and also please like the session. Because I've spent so many hours oh my god, I've spent 4 hours teaching you approximately. So please like the session and also leave feedback, leave comments for me, for me to read. Because after the session is over, I get bored. I want to read something. So please ask me doubts. Please answer homework questions. Please talk to me in the comment section. Thank you so much. Bye bye.